as we all know that there are so many types of biomass which are coming into the picture. Like initially it was only the first generation biomass, which does not meet the which somehow affects the food quality of the it is the first generation biomass which are food dependent biomass. So after that, the agri residues which is being generated, which is being collected from the first generation, is the second generation biomass. Same as we have the third generation and the fourth generation biomass. So but as we know that there is a large number of waste that is being generated because it's agricultural land, so we have a large number of agri waste, a large number of municipal waste. So many waste are being generated every year. It's being generated. So these second generation biomass is utilized here, is being used here as a resource for converting this into a biofuel. But there are still like every there are still so many challenges which are need to face with the biomass. The important one is the challenges, how to overcome the challenges. So first is the biomass production. So the biomass production is very important. Like we know that there are so many of the biomass which are the second generation biomass, which are the agricultural waste which is being generated. But making the farmers aware of that this biomass can be further utilized for the other purposes also. So there this kind of production is need to be done. It's very important actually these days, because they know some farmers are not aware of that, so they generally go and burn it, due to which the pollution also increases. So making the biomass production in a very large amount, since nowadays we are working more on to the industrial level. At an industry where this is actually due to some good policies which are given by the government of India, there is a great area or the scope where the biomass production is important. So making the farmers aware of this biomass production is very important. So this in this category there are so many of the agricultural industries which are working on it. Then after the production, the biomass collection is also very important. Collection, how to collect those biomass, what is, since there are lack of harvesting technologies still we are facing, there are lack of the terminal for storing the biomass, there are uh, lack of the transportation in the biomass. So these are the major challenges which we are facing. Sometimes we are not having the feed stock so that we can get the desired product. So in that case, this is actually playing a major challenge in the biomass collection and the biomass production. After that, the mobilization is also playing a very important role, how to transport your feedstock. So this all together comes into the category of the feedstock supply. The feedstock supply is very important before setting up any industry, or before setting up the plant for the biofuel production or any of the fuel production that is totally a biomass based. For that, the feedstock supply is playing a very important role. Next is the technological option, which is actually it's a big scope for the R&D level. Like the bio and the thermochemical process units are there for the biological, for the production of biofuels. But the technological options are very limited in the sense that it has some of the limitations. Currently it has some of the limitations in the technological point of view. Like there are still the biomass conversion technology, a lot of R&D scope is there for the biomass conversion technology. A lot of R&D's related work has to be done at the industrial level, or at a small scale plant, or at a pilot level plant. So there is still a lot of chance of doing some good R&D at the technological option point. Then the end product, the making the market aware of the your end product, making the market aware of the biofuel is also very important. Sometimes the motor engines are not ready for using the biofuels. So such these kind of challenges are still there with these existing technology. Then since I have already told that we have agricultural waste generated every year, so this is being generated globally. A large amount of waste is being generated, which is the agricultural. See, we are the agricultural country, so we have a large number of agricultural waste generated every year, which accounts to around a high metric tons of the years we are generating the this. Now this global productivity of these agricultural waste can lead to the production of a large amount of the second generation biofuels, which can be the bioethanols or bio CNG. So there are so many options by which we can use these agricultural waste. So also we have a globally we have a food processing industry. So food processing industry is also one of the very good good options for taking this as a feedstock for converting your fuels, for producing your fuels. As we can see, a large number of industries worldwide has already been there and is working on the biomass waste for ethanol production. So, overall, one can say that there is a large scope of the feed waste which is being produced every year, which is being produced from the different industrial sectors, and these waste can be utilized as the for the ethanol production as well. Then we let us come see here. I'll be discussing about the total all the fuels which can be either produced by any of the thermochemical way, by any of the physical, thermochemical, or biochemical way.
आपसे
So
मिलना
this is
हर समस्या का निवारण है आपसे मिलना
hello.
हर समस्या का निवारण है स्वागत
I
करते
would
हैं
like to
आपका
request to Sunil
आप
Gele
हमारी
sir,
प्रेरणा का
kindly switch
कारण
off your
हैं
mic.
आप
So thermochemical biomass process and product is like here a large number of lignocellulosic biomass can be converted into the different fuels. It can be a solid, liquid, or it can be a gaseous fuels. So there are different methodology. There are different processes in which by which we can do this conversion. So first is like the physical. Physical these biomass can be treated like crushing, grinding, or pelletizing or briquetting can be done for making the solid fuels, which can be used in hot water generators, which can be used in boilers at all. So these kind of fuels can be utilized there by doing the just the physical treatments. Then the thermochemical treatment, which is somehow we are giving the temperature and the desired condition to the system, to those lignocellulosic biomass, or say we say it's as a waste biomass, which produces a large number of different fuels like your syngas, your heat energy, bio oils, biochar, which is produced by different. There are different process of being of producing those biofuels. Next is the biochemical, which we all know that it's a very common and it's a commercialized process like the fermentation, which is majorly required for producing the bioethanol, whereas the anaerobic digestion is for the biogas production. So we have a large number of biogas and bioethanol ways of producing these different fuels. The important is key we have, since we are at this platform, so we there are still some of the existing process, like I have already told that hydrolysis fermentation, it's a best way of producing the bioethanol, but still it has so many of limitations. So for the R&D point of view, we need to do something different from these fermentation process or from the hydrolysis process, because these have its own limitations. Same as with the biogas also, it's anaerobic, although people are still working on the biogas area so that we cope up with these conditions, and rather than the anaerobic digestion, because these are again producing a large number of CO2s are being generated by using this biochemical method. So there is a great scope of doing the R&D at this area. So let us come directly to the biofuel, which on which I was going to discuss in my coming slides, is about the 2G, the blending of ethanol into the petrol that is being given by the National Biofuel Policy by the Ministry of Petroleum and Natural Gas. According to them, the biofuel policy has several visions and goals. Like the blending of ethanol in petrol is required, which comes under the which comes under the biofuel policy. Setting up the 2G bio refineries, setting up a 2G biorefinery. 2G means the second generation, which is the second generation which are basically the lignocellulosic biomass, which consist of the components like your cellulose, your hemicellulose, and lignin. So this is different. This is where we are going to work on. Then development of a new feedstock. So feedstock development is very important. Like currently we are working on the agri residues. That is a second generation biomass biofuels, but there are still so many possibility of finding out the different feedstock. Like there is a possibility of finding out the your fourth generation biomass, which are basically the carbon capturing and storage. That is also a lot of people are working on the second generation of carbon capturing process. However, the third generation, which is the algal biomass, which is also used as for producing the different biofuels, specifically the ethanol. So therefore, based on the biofuel policy, this vision and goal has been set up to focus more on to the advanced biofuel technology that is different from the commercialized biofuel. Because if we are doing some good R&D, we need to do something in an advanced level, and we need to do something which are not still into the market. So based on that, as I have already told, that there is a different biofuels. So which is basically divided as the feedstock basis and the commercialization basis. Feedstock basis, I have already explained that there is a first generation, second generation, third generation, and the fourth generation biomass. Here we are considering the second generation biomass, keeping in mind that okay, this is an agricultural land, and we have a large number of waste sorry, so we have a large number of waste generated every year. That waste is need to be utilized, and that waste is need to be converted into some of the good resources or in some of the good product. Also, the second point was like if we have a large number of waste generated every year, it will keep on burning. Farmers will keep on burning. So, in order to utilize those, this is the best way of utilizing those lignocellulosic biomass and converting it into the biofuels. Second is the commercialization base. So, commercialization base, like we already have a conventional biofuels which are commercialized one, like the anaerobic system is there, anaerobic digestion is there for the CBG production, and the fermentation and the hydrolysis is there for the bioethanol production. But still there are so many chances, because it has its own limitation, as I have to. So still there are so many chances of producing the advanced biofuels, which need intensive research. So like the advanced biofuel need intensive research. Now, what are the identified areas for the R&D where we can work on this? Is the biofuel feeder stock production, like what kind of biofuels we can use. There are different types of different feedstock can be utilized for the purpose. And then there is advanced conversion technology. Like currently we are dealing only with the fermentation, more known fermentation process and the anaerobic digestion process for different biofuels. Like the gasification is also there. Some of the thermochemicals which are also there in the which are already there in the picture, but there are still some of the advanced technology which is need to be identified to convert those feedstock into the biofuels. So that is very important, where the R&D work can be focused on. Then using those technology to modify the biofuels, to increase the yield of the biofuels, to reduce the side products, to reduce and so that the yield of the desired product increases. Also the utilization of byproduct, if some of the byproduct is being produced, then what to do with those byproducts, and what how to make the how to generate the revenue from those bioproducts. That is also very important perspective for the R&D perspective. So, concluding all these pictures, I would like to explain that there are the various routes. I have already told that there are various routes for the ethanol production. So, from the biochemical and thermochemical, we get the ethanol. As I told that there is a fermentation and the hydrolysis process by which the biochemical ethanol is being produced. But the thermochemical is one of the route that is required to produce the bioethanol, either by the gasification or by the chemocatalytic. Now, this chemocatalytic is the advanced technology, which is not the commercialized one. But yes, a great research is being conducted with the chemocatalytic pathway as compared to the gasification and the fermentation. So, for the fermentation, the biomass waste undergoes the pre-treatment, then it can be undergoes through a series of the different processes there, like your separate hydrolysis fermentation can be one way of producing ethanol. Simultaneous saccharification fermentation might be the another way of producing ethanol. So there are so many ways of producing ethanol by using the fermentation routes. And for the gasification, the gasifier is being used for making the biogas, converting into the syngas. Then these syngas can be used either goes through the fermentation process or through the catalytic reactor to produce ethanol. So based on these two, the other chemocatalytic path is came into the picture, which is the advanced route for producing the ethanol. So this includes the integrated synthesis of ethanol from the cellulosic biomass. So here one pot synthesis is being required, and here a different series of catalytic reaction is being carried out at different conditions with the by using different different mechanism. So by those we can just undergoes through these process, like converting cellulose to glucose, which requires the hydrolysis. Then after that, the hydroalkyl condensation takes place, like cleaving the bond of CC bond of glucose to form the C2 and C4 compounds, which are glycolaldehyde and the erythrols. Then further it undergoes to hydrogen to produce ethylene glycol and ethanol. So this is the complete chemocatalytic route on which the complete research has been conducted, and this has its own benefits, or it has its own beauty of producing the ethanol. Before coming to the experimental part, I would like to explain that we have also performed some of the techno-economic comparison. I have a good results of the techno-economic comparison of the three routes, which is the chemocatalytic, thermocatalytic, and the thermocatalytic, that is gasification via syngas, and the fermentation. So based on this, one can see that the minimum ethanol selling price, which is the MESP, is the lowest for the chemocatalytic route as compared to the other two, whereas the capital investment for the capital investment is like for the gasification, the additional step is the syngas cleaner, because it has a lot of impurities which is being generated by in the gasifying unit. So that is need to be cleaned up, and then the gasification itself is costly, so that add an additional cost to the gasification steps. Also the enzymatic hydrolysis is also added the cost of the enzymes. So when we compare all those things, then like the variable operating cost for the feedstock is highest, and but for the catalyst for cost for the chemocatalytic is still high. So there is also, again, there is a scope of work on like anyhow, if we can reduce the cost of the catalyst, reducing the cost of the catalyst may affects more, may reduce more MESP, or may reduce the more the MESP of the chemocatalytic route. So here, after performing the process sensitivity of the chemocatalytic route, one can see that the catalytic cost increase, catalyst cost and the biomass cost are directly affecting the MESP, whereas higher alcohols and ethanol yield are negatively impacting. That means if anyhow we reduce the cost of the catalyst, then in that case the MESP will obviously reduce. So in that is very important. So this is again a area where a lot of R&D can be performed, that how to reduce the cost of the catalyst, or what kind of catalyst can be, how cheaper catalyst we can use, so that the cost reduces, because the major cost which comes from the variable operating cost is the catalyst cost. If we reduce it, we can get more better values. Same is with the biomass cost also. Biomass cost include your transportation cost, your every cost is being included there. So if that meets your criteria, if your biomass production unit is near your plant, in that case the biomass cost may also be reduced. Second is how to increase the yield of the ethanol. Like we are not we have not reached to that value where we can get a very, like we are still away from the theoretical value of the yield. So when if we increases the yield anyhow, in that case also it will be helpful for us. So okay, so based on these data and based on these studies, one can conclude that the fermentation having a slow dynamics, enzymatic dynamics, so as it has its own limitations. So basically, the slow dynamics of enzymatic catalysis, also the synthesis of every molecule of ethanol emits CO2. So CO2 is actually causing a major problem. So as per our policies, also the CO2 emission, a lot of people are still working on the CO2, how to reduce the CO2, how to make the process so that no CO2 is being generated. So keeping all those in mind, the fermentation is not a right choice for this particular work. And in fact, the gasification also, it has a lot of impurities, of which removes a gasification, which required a gasification route, so which obviously added a method to the costly method, which is again a costly method. So in order to meet all these limitations, that this is the techno chemocatalytic is a new pathway, is a new technology which is being developed, and but it uses a large number of it uses a catalyst which is still a multifunctional catalyst that supports a cascade reaction. So we need to design the catalyst in such a way that it supports the cascade reaction. Also, it reduces the side reaction, and the zero CO2 is being emitted by using the chemocatalytic. So based on these understanding from the literature, it was supported that the chemocatalytic is actually it's actually a development of a new technology. So based on this, the kernel density plot for ethylene glycol production was generated. Now for ethylene glycol, why? Because ethylene glycol is an intermediate of ethanol. So a lot of work has already been done for the ethylene glycol, but for ethanol there are very limited work which was already which is there. So based on that, one can see that how to decide the catalyst, how which catalyst is more prone for forming your ethanol. So based on these studies, we have conducted that there are, what is the role of tungsten, and tungsten is actually playing a very important role. So based on those studies, we have concluded that okay, there's a tungsten based catalyst and a non tungsten based catalyst. So when the ethylene glycol, by plotting the kernel density plot, we have seen that the kernel density plot for the ethylene glycol is giving us the better, for a tungsten based catalyst is giving us a better result as compared to the non tungsten catalyst. So based on these understanding, the tungsten based catalyst has been chosen as the catalytic system, chosen into the catalyst system, where and after that such reactions are being performed. So this is the chemocatalytic conversion pathway, which involves actually the two step. Initially it came into the picture at 2017. So here the two step process was involved, but again the two step has its own limitations, like it is more energy intensive. It chooses a lot of catalyst and intermediate which could make them effective and expensive to operate. So based on these limitations, the one step process came into the picture, which shows that there is a, which overcome the limitation of the two steps. So one step is basically it's like a one pot synthesis of the ethanol. So this is the chemocatalytic conversion of cellulose to ethanol by using PTTiO2 as a catalyst. So this is basically this was the experimental setup which was conducted for the lignocellulosic biomass. Here taking the reactant as a microcrystalline cellulose. The synthesis, the catalyst was synthesized using the different methodology. As I have already given a picture of one, just to explain that what exactly steps we have followed. Then from this we can see that basically there are two reactions pathway. one is leading to the form One is leading to the formation of ethanol, and second to the propanol. So ethanol and propanol both are being produced, but the important is like what to do so that we get majorly the ethanol rather than getting the propanol. So when the glucose is isomerizes to fructose, it will further convert it into the, it will follow the reaction pathway too, and will produce propanol rather than producing the ethanol. Or so this studies is being conducted here, that how what are the important factors, what are the important point of the glucose where this step should be suppressed, the propanol formation step suppresses, and the ethanol formation steps is being enhanced so that we get the better yield. So for that particular purpose, the catalyst is being synthesized, which is then characterized. So these are some of the characterization I have just shown here, that how to the XRD was performed to find the phases and the latest structure of the PTTiO2, which shows that the TiO2 is a tetragonal crystal structure and PT is a FCC. So these are some of the characterizations that was performed just to find out that what kind of catalyst is being produced, what is the structure of the catalyst, what is the oxidation state of the catalyst. So from the oxidation state is like we can clearly see that from the XPS data that the TI is in the form of TiO2 and PT is a metallic form. Again, the morphology of the catalyst was also was analyzed by using the FSM and the HRTM image, which shows that it's a rod-like structure, rod-like morphology, and the 2% of PT was loaded, which was confirmed by using the ICP-MS. Also, the PT, the qualitative presence of PT is also confirmed from the fringes image, which we can see in the HRTM image, which shows that there is a loading of PT. So after that, the catalytic activity of chemocatalytic conversion of cellulose to ethanol was conducted at different temperature and time. So here a lot of experiments was performed for finding out these conditions, but I am just here showing that the two temperature and the time, how it is majorly affecting. So when we can see that the ethanol formation increases at 222, when we increases the time from 5 hours to 2 hours, the ethanol formation increases, but on increasing further temperature, from 220 to 250 at 5 degree also. The ethanol formation increases. That means at higher temperature or at high, but it is still less than that of the 220 at 10 hours. So after that, the further temperature and the time was increases. So one can see that at higher temperature we can see the formation of propanol as well, whereas at lower temperature there is only the formation of ethanol. From this point we can conclude that the higher temperature is favoring the formation of both ethanol and propanol, but at the lower temperature we are getting only the ethanol. So this is the conclusion of this work, that we if we wanted to solely produce the ethanol, we cannot go beyond 220 or 220 actually. So we cannot go beyond 220. And if we wanted to produce both C2 and C3 alcohol, because C3 alcohol, which is propanol, is also a cost addition. So if we wanted to go for the C3 alcohol, we can also go for the propanol formation. Propanol is also well used product in the everywhere. So this is what is being suggested from this study. Also one can see that there is no major difference on increasing the temperature for ethanol, like from 220 10 hours to 250. The yield of ethanol is almost same, but the yield of propanol varies. So from here, the XRD of spent was also being calculated, which shows that how your catalyst can be affecting after putting it into the conditions like temperature and pressure or height, when we are giving them. So we can see that there is not much changes in the XRD plot for the spent 1 and 2, which is at lower temperature. But at higher temperature some of the peaks appear, which might be due to the residual stress which is being generated at higher temperature. So we better we go for the lower temperature where we are getting the higher amount of ethanol as well. So after that, the catalytic activity was also performed for the tandem catalytic reaction, in which it was important to decide that how to, like in the tandem catalytic reaction. First, we were only performing with the PTTiO2, but as we got to know that there is also the importance of H2W, means a tungstic compound. So how to add the tungstic compound? So rather than building the tungsten compound onto the main catalyst, we use the tungsten compound or tungsten catalyst as a co-catalyst. So then the importance is how to feed or how to put into the system those catalysts. So first is like in the first step there was a sequential addition, that is a tandem catalytic system. So here first your H2WO4 was added, and later on after a certain time your PTTiO2 was added. It was not added together. So for when we do so in the first step, we can see that there was no ethanol, only the propanol formation was there, which means that propanol, there is also the possibility of getting the propanol from the tungstic acid as well. For the In the second step, after certain time, we have added the PTTiO2 also, in which we can see that by adding the PTTiO2, the ethanol formation was also there, as well the propanol is also there, but there is no major if changes or major increase in the yield of the ethanol, which is almost same. But with the integrated system, when both the PTTiO2 and tungstic acid are added together, in that case, we have seen that there is a increase in the ethanol yield, and the propanol yield is almost reduced to a very lower amount, lower values. So therefore the PTTiO2, when we are added these all together into the integrated system, adding it together, the impact is totally different. Thus, one can also say that when we are adding the hot water and the tungstic acid, in that case, one can say that since the glucose formation is there, which is due to the hot compressed water, which is being generated at a higher temperature and pressure, in that case, the cellulose chain breaks, and the glycosidic bond break to produce the glucose. So this is one of the study which was conducted by Kandya et al. It is a very good studies for the hot compressed water, in which they have shown that these, not only your simple water is sufficient for hydrolysis of cellulose. So like if we are providing them a high temperature and high pressure, even at 180 the heterogeneous hydrolysis is taking place, in which, if that means the cellulose beta 1 for glycosidic bond bond is being cleaved out, which further on increasing your temperature from 220 to 260, we can see there are different product that is being formed. That is the glycolaldehyde is also being produced, which is one of the intermediate of ethanol formation. And on further increasing the temperature to 260, again your formic acid, acetic acid, and lactic acid is also being produced. So then there was the various studies, like if we use the tungstic acid as a co-catalyst, and we need to compare all the Kagan's type of structure for the tungsten based co-catalyst. So in that, one can see that the ethanol yield for the tungstic acid is highest as compared to the other tungsten based compounds, uh, which has its own, because these are the Kagan's type of structure, this distorted at higher temperature. So that is some of the limitations with the other type of co-catalyst. So here the trend for the formation of ethanol was follows this order of tungstic acid is giving the highest yield, then the ammonium tungstate, and then the phosphotungstic acid. But we can also see that your tungstic acid and your phosphotungstic acid is also producing the tungstic acid, and is producing your propanol as well, but the other compounds like phosphotungstic acid is not producing the propanol. So that is what then the product distribution was also was conducted for elucidation of reaction mechanism, like for how to find the reaction mechanism. For that purpose, like the product distribution is important. So for that, different catalyst was taken into the picture. Then the different reactant was also taken as a for conduct like taken for finding out the desired yield or product yield. So from those all these results concluded us that there is a reaction pathway that is being followed here, which shows that how the activation and the cleavage of a specific CC and CO bond for the formation of C2 and C3 alcohol, C2 ethanol and propanol alcohols uh, is being explained here by from the different experiments that is already being conducted previously. So based on this, one can see that if cellulose was converted into the glucose undergoes the retroaldol condensation, which gives the glycolaldehyde at erythrose. The glycolaldehyde on further hydrolysis by using the PTTiO2, the ethylene glycol is being formed, and from that ethylene glycol, the ethanol is also being using the hydrogenation reaction. It also converts the ethanol. Moreover, the glucose also undergoes the sorbitol, which is also being one of the major product which is being produced. But here, since we after using the tungsten-based catalyst, this cleavage is actually taking place. The CC cleavage of glucose is actually taking place, which avoids the formation of sorbitol and fructose rather than forming the formation of glycolate and erythrose. Also, if the glucose undergoes isomerization, it will further goes to form the formation of glycerol and the propanol. So these all intermediates is being calculated based on the product distribution at various temperature, at various with various reactant and with various catalysts. So this is the entire mechanism, we can say it's a entire the reaction pathway that is being concluded from the experimental results that we have that I have already conducted. After that, the stability test was also performed for the PTTiO2 catalyst. So here one can see that it is almost same. It is the catalyst activity. The product yield does not decrease up to the 4 runs, third 3 runs, but after 4 runs it started decrease. After 3 runs it started decreasing. Thus, therefore, we can have a good R&D scope at this point also, where we synthesize, or where we do the synthesis of such catalyst which gives you the higher strength, which does not deactivate after some time. It increases the number of this a number of runs. So that is also very important. The stability test or perform preparing or synthesizing such kind of catalyst which has a higher stability is very important. It's a good point where the R&D can be conducted. So after that, after using PTTiO2, the another work was also conducted for ruthenium over WO3 catalyst. Here, there I was using WO3 as a co-catalyst. Sorry, tungsten-based catalyst as a co-catalyst. But here, the tungsten-based catalyst is now used as a support. So let us see what is exactly happening when we use the tungsten based catalyst as a support. So here this is important. Like if we undergoes the ruthenium loaded WO3, so the cleavage and isomerization both is taking place. Cleavage means you are getting the ethanol, and isomerization means the fructose is being formed, and which is also going to give you the propanol. So cleavage and isomerization both is taking place. So but if we are using the addition of WO3, like along with the RU loaded WO3 is also used as a catalyst. In that case, one can see that the ethanol is only produced and no propanol is there. So this is one of the interesting studies that is already being conducted, which shows that how you can suppress the formation of propanol and how only the ethanol is being formed. So again, there are different steps which is being followed, which is their experimental details which is already given. And this is the synthesis part, which is for synthesizing ruthenium loaded WO3, and there are different characterizations technique which was already performed for different like XRD, XPS, for just to identify that what kind of catalyst we are getting. Here, the important point is about the cleavage of glucose is important, as we have discussed later in the earlier slide also, that the cleavage of glucose is important. So here we will be more focusing more on to the cleavage of WO3 experimentally. Theoretically, I'll be not discussing. Experimentally, I'm going to discuss here. So this is very important, that how to discuss the how to cleave this bond. So WO3 is actually playing a very important role in cleaving this bond. So like cellulose undergoes water and hydrolysis. Hydrogen is there, which undergoes the retroaldol, which forms glucose by cleaving its bond, and then it undergoes retroaldol condensation, then hydrogenation to form ethylene glycol and ethanol. So these are common steps which was already there explained in the previous slides. Now again, the phases and the lattice structure was identified. So for this, WO3 is at the hexagonal, and the monoclinic WO3 phases are there, and the ruthenium is at the ruthenium. Can we can see ruthenium from the XRD at 2 theta value of 42.14, which attributes to the peak of hexagonal metallic ruthenium. So from the HRTM images also, one can clearly see that there is a loading of WO3, ruthenium on WO3 nanorods. WO3 is at nanorods, and ruthenium is loaded onto WO3, which can be clearly seen from the image, HRTM image. Also, the fringes can be seen from the HRTM image, which shows that there is a qualitative presence of the ruthenium on WO3, which correspond to 002 phase, along with the two phases of WO3, which is at 0 to 0, and here one can say 0 to 0 and 0 to 2. The electronic property further confirms the oxidation state of the W and the ruthenium. So W is in the form of W6 plus, which is WO3, and ruthenium is at a metallic state. Now there are different catalytic activity which was performed in order to optimize the reaction parameters, in order to optimize the product yield. So there were different conditions which was conducted, like at a temperature, time, cellulose loading, and catalyst loading. So for the cellulose loading, sorry, for the temperature, one can clearly see that the at 523 that ethanol yield increases. So we are considering here the ethanol yield as the desired product. So at 523, one can see that the ethanol yield increases. So however, the optimum time is 10 hour, where the yield is 28.94. Similarly, the cellulose loading was conducted for different cellulose loading. The amount of cellulose was fed into the reactor, and based on that the product yield was calculated. So the optimum condition from this table can be concluded that the temperature is at 523, the time is at 10 hours, the cellulose loading is 200 mg, and the catalyst loading is 100 mg. So after that, the investigating the effect of WO3 as a co-catalyst. Once we get the different parameters, different optimized condition of for the catalytic system, there was an investigation which was performed when we use WO3 as a co-catalyst, and here when I use WO3 as a co-catalyst, the result was drastically different. First, the reaction, sorry, first the reaction was performed for the blank reaction, in which one can see that there is a formation of sorbitol, which is mainly due to the presence of hydrogen into the system, and which led to the in which the glucose gets converted into the sorbitol. But when we use the WO3, then there is a formation of a clean glycol and the other product as well. However, when increasing the Raju loaded WO3, which results is same as given in the last table, which shows that the ethanol formation is around 28.98. After that, when we added WO3 onto the system of RU loaded WO3, one can see that the ethanol yield increases to around 44-45%, and the other byproduct reduces to almost negligible points. Uh, Further, so this is being done when 50 mg of WO3 was added with RU loaded WO3. That means the WO3 is actually playing a synergistic role of on RU loaded WO3 to promote the formation of the ethanol and reducing the other byproducts as well. So in the next step, when the WO3 concentration increases, or it's when the amount of WO3 increases, one can see, although there is again the product of there is the formation of ethanol, but the yield reduces. The reason behind is maybe the excess WO3 might block the active sites of the catalyst, and that's why this has reduces. So the major conclusive point that is being generated from these studies is that when the WO3 is coming into the picture, it's being added into the system. In that case, WO3 cleave this bond C2C3 bond of glucose, and when it cleave the bond of C2 and C2C3, the other products like the sorbitol and the propanol, which is due to the fructose which is due to the isomerization of fructose, is not taking place, and that led to the formation of the cleavage bond. So one, the cleavage is bond, the 2 plus 4 compounds we are getting, and that 2 plus 4 compound will be further converting into the C2 alcohols. So from the XRD pattern also, one can see that for the blank reaction, the XRD was conducted, which shows that the crystalline nature of the nature of the cellulose also changes to its amorphous phase, which shows that there is a solid residue which is about to generate is about 1.5%. That means the conversion of cellulose is not the 100%; it could be around 98 to 98.5%, because the solid weight residue is 1.5%. So after that, the XRD pattern of the catalyst was performed, which shows that the less stable phase of the catalyst disappears under these conditions, and only the stable phase, which is of the RU loaded WO3, is being there after applying the conditions. So then the reaction pathway again was proposed for this particular reaction also, and for based on the different reactants like cellulose, glucose, fructose, glycolide, and ethylene glycol. Based on this, the reaction pathway is being is being evaluated, which shows that your glucose undergoes the cleavage of sorry which shows that glucose undergoes the cleavage of C2C34 let C2C3 compounds led to the C2C3 carbons led to the formation of the glycolaldehyde, when by adding RU loaded WO3 and WO3 in combination led to the formation of ethylene glycol and then ethanol. Whereas for the when RU loaded WO3 was only used, then it led to the formation of fructose as well, and giving the yield of propanol as well. However, your when H2 was using there, or the RU loaded WO3 was only using, in that case the hydrogenation of glucose is taking place, which led to the formation of sorbitol. Also, there is a chance of the oligomerization of humans, which is basically that solid residue which is being generated. So that is also possible for the humans formation, which are dark colored dairy solids. So from these studies, it was concluded that when we are solely to form the ethanol, we should use some kind of the tungsten based co-catalyst, so that it enhances, or it provides that synergistic effect to the main catalyst, so that it promotes the cleaving of C2C3 alcohols. So now again, the stability test was conducted for this particular catalyst also, and from here also one can see that after the 4 run, the yield reduces a lot. Now, from the above studies, all the studies, it was concluded that there is a possible overall reaction network for cellulose conversion to ethanol and propanol. So this is the possible overall reaction network. for cellulose conversion to ethanol, which shows that there it follows the different pathways like the R1, R2, R3, R4. So there are different reaction pathway that is being denoted here as given here in the R1 denotes the hydrolysis, retroaldol condensation of glucose, hydrogenation. So this is the possible reaction, entire reaction network based on the studies that was conducted previously. From the current studies for the RU-loaded WO3, there were few assumptions which was made based on the experimental results, and from those experimental results, one can conclude that the RU-loaded WO3 and WO3, when it was used in a combination, then there was a selective production of ethanol is taking place. So therefore, reducing this is why we are doing. We are just trying to reduce or find out some of the good kinetics for our system that is based on our experimental studies. Then the hydrogenation of glucose to sorbitol is also not taking place when we are using the cellulose as a reactant. So therefore, neglecting R3 also, humans formation is also negligible because when we are using cellulose, the humans formation is almost zero. No gaseous product was also formed. So based on these assumptions, there was certain again, some of the testings was conducted for glycolaldehyde as an intermediate. So there were again some of the parameters were concluded, which is based on that by doing the mass balance of these reaction pathway, we get that there might be the accumulation of the erythros and the accumulation of glucose. But when the glycolaldehyde was used was used as a reactant and the yield was calculated based on those studies, one can conclude that there is no erythros and no glycolaldehyde is being formed. That means the accumulation of these two is also zero, and no byproduct was also formed. So based on all these assumptions, this reaction pathway is being computed, which shows that it follows the series of cascade reactions starting with the cellulose to glucose to glycolaldehyde, ethylene glycol and ethanol. So based on these, the results were obtained from the differential equation, which gives the final concentration of different reactants. If we know the kinetics of these parameters, if we know the kinetics of these parameter, we can directly calculate the concentration of the different reactants. So that this is one of the possible way of finding the or this is one of the possible way of finding the concentration when we know the kinetics. So there was also the effect of temperature and time was studied to find out the kinetics parameters. So here one can see that the cellulose conversion and the ethanol yield was calculated at different time and at different temperature. So based on these, the phenomenological model was developed for the cascade reaction. For the cascade reaction, which shows that the C model values as this, and from the by fitting these parameters by doing the simulation of these parameters, the K1, K2 values is being calculated for different time and temperature, and after that the it, activation energy was also calculated from the Arrhenius law, which shows that which is given which shows that the CC cleavage of glucose, which is the R2 reaction, is crucial and also important and is determined as a rate limiting step. So this is the model validation which was done. So this model validation is based on the experimental and the model value, which is well fitted. From here one can see that the accuracy is even 0.98 or even higher. That means it is well fitted model for the experimental setup. Experimental and model values are satisfying. So based on this, this is the over conclusion of the present studies, which shows that okay, with the replication of an increase in ethanol yield in the industrial process, we can benefits the sugar mills if we are considering the first fermentation process, or which meets the target of E20 blending, which is given by the blending ethanol blending program. Also, the techno-economic shows that the minimum ethanol selling price for the chemocatalytic is lowest. Whereas compared to the biological pathway, chemocatalytic approach is more efficient in terms of processing time and atomic efficiency. The chemocatalytic pathway for ethanol synthesis in a single vessel is complex. It involves a sequence or a subsequent series of subsequent reactions. The tungsten-based catalyst is also very important, and it improves the CZ cleavage along the retroaldol to take place. And there are the addition of WO3 as a co-catalyst also suppresses the formation of C3 alcohols and promotes C2 alcohols. So based on these, the reaction kinetic pathway for cellulose to ethanol conversion in an integrated system was conducted and which shows that there are different, which is used to evaluate the kinetic parameters. Thank you so much.
Thank you so much, ma'am. Now I would like to request to any one of the participant does have any questions. Does anyone have any questions regarding this session? They can
No,
ask.
sir, it was a wonderful session.
Okay, ma'am. We proceed.
Yes.
Does anyone have a questions? Okay, ma'am. Now I am asking it to you. That as you are
Yeah,
saying
sure.
that E20.
Hmm.
एक्झिट कर नंतर
Yes, sir. We proceed, sir. I think they left the session. Actually, ma'am, as you are saying that the government is more focusing on E20 blending.
Right.
Okay, but also the government is also planning for the E40 blending, kind
Right,
of
right. That's
increasing the blending of ethanol into the petrol,
right.
ma'am. So as you are, ma'am, saying the different kinds of propanol and butanol is also be an options in a futuristic petroleum or in a oil sector. So, ma'am, don't you think like that rather than increasing the blending, we should have to be shift for the propanol and butanol?
This work was actually conducted based on the ethanol blending program, which was, I think, in 2016. It was there. There was a requirement of E20 blending. Even it was 15 only. Okay, so there was a 15% of ethanol was need to be blended into the gasoline. But right now, but into the petrol. But right now it increases to 40. That is very true. E20, why I'm saying, because this work was focused on the time when E20 targeted was there. So this work was focused on that. But yes, there is still requirement of increasing it to blending. Why I'm saying blending? Because currently there is as I have already mentioned that, Sarah, there are several challenges. The last one challenge was the market. Okay,
Yes.
so we are not that much aware of, so that we can change the engine and just go for the other fuels. Like you are saying, the ethanol, we can solely use ethanol as a fuel rather than blending it. That is true. That is one of the possible way in the future we can adopt for. But currently the market scenario is different. We have to work on that. It is actually very important that rather than depending partially on petrol and partially on ethanol, we can kindly focus on some of the fuels which are totally dependent on the one, like non-renewables one. So that is true. But currently our market strategy is not that way, so that we can, at this moment, we switch to the completely that kind of motors. So because that motors are not being even supported right now. But yes, it is the initiative that has to be taken. And I think in the future also there is a perspective, there is a future plan that such kind of things will be taken even after 10 years or 20 years. That is true.
Thank you, ma'am. You are right, ma'am. But also, ma'am, as the topic suggests that we are also focusing on the renewable energy system. So, just I want to also clarify my curiosity that does the E20 blending can helps in carbon emission?
it cannot completely remove the carbon emission. That is very true, but that is what I'm saying. Currently, what is there, what the commercialized process are they are following, the commercial technologies are the fermentation one. So in the fermentation we are definitely getting CO2. So we cannot say that the CO2 is not at all being produced. That is why this advanced technologies came into the picture, but this is still not commercialized. A lot of work or the R&D work is need to be done, so to make this commercialized. But that's true that CO2 emission is there, CO2 is not at all depleted, yeah, but there is also the possibility, like people are also working on the CO2 capturing technology. So that is one of the additional way to the technology that can help somehow, so that we can capture those CO2, and that CO2 can also be converted into ethanol. So
So,
that is different mechanism, but this possibility is there. So if we add those technology with this fermentation technology, there is a possibility that CO2 emission may reduced, not up to that level, but yes, up to some level, by
so,
using that some of the by using that CO2, by capturing it or converting it to some of the process.
so ma'am, how can we
People are
further?
still working on the carbon capturing also. A lot of work is already being done in the carbon capturing.
Yes, ma'am, because this kind of curiosity I have arised in my mind just because there's you are seeing in recently newspaper that kind of air quality index has been grasping down
Right,
into the New Delhi. So
right,
we always try to do a odd, even and kind of different
right.
grade four types of formula into the New Delhi, our capital city. That's why I'm asking you. Also,
Yeah,
ma'am,
that is true.
also,
Hmm.
one thing I've heard in my newspaper that government has to be planning for E85, ma'am. This is also a term that has been coined up in the newspapers.
Yeah, government is planning, but I don't think that there is much R&D work is being conducted. Maybe the people are still started doing it. This is one of the process in which the CO2 can be converted into the emitted CO2 can be converted into some of the other fuels. Like there is one of the best way by using the catalytic system only. There is a possibility of converting your CO2, capturing it and converting into the higher alcohols. Higher alcohols means ethanol and propanol, not methanol.
Yeah,
Ethanol and propanol is being converted, so maybe by using those technology, this kind of things can be arrived in the future.
right, ma'am.
Yeah.
So, ma'am, does we have to plan apart from the E20 blending? Should we have to
Yeah.
proceed for the further research, like as you are highlight in the your PPT session, like a propanol and different kinds of uh,
Yeah,
inputs
actually, what is
systems.
happening? See, we have different sectors. Like we can also produce the CBG also. Like currently, the CBG boom is there. Even this biofuel boom is there. So, but the problem is we have to anyhow increase the yield. In a meanwhile, we also need to reduce the emissions of the carbons or the other impurities which is being generated every time. Like for the CBG, also, there's such things are we are facing. That is a large amount of CO2 is being produced until unless we do not have other technology to be adopted as an alternate technology or as an additional technology to capture those CO2. This is quite not possible. But yes, a lot of R&D is still required to do in this sector. The reason behind is because currently the industry or whatever the industries are following there, they are just trying to capture those, but they are not converting it, or some maybe some other industry might be converting it. The important point is like when you wanted to do some of the good R&D, in that case, first, like CO2 is very important problem, like that is we are facing every time. Like in Delhi, it's a worst scenario right now. Maybe after some time the other cities might also be affected by using by this thing. So the important point is like you are supposed to utilize those byproduct, because CO2 is coming as a byproduct. Rather than wasting it or just putting it into the environment, we have to capture that. And the second is like yes, there is a chance of using some advanced technology. Like for example, the chemocatalytic one which I have discussed recently, this process does not emit CO2. The beauty of this process is like it does not emit CO2. It's a very clean and a green process. That's why we call it as a green process, because it does not emit CO2. But again, it has some of its limitations. Like it uses some of the good gas. costly enzymes, might be the synthesis of the costly enzymes is also cost effective. So there is a great good scope where we can work on these parameters. When we can reduce the cost of the catalyst, we can increase the stability of the catalyst. But yes, there are still some of the process which can come into the picture later on, which shows that your CO2 emission is reduced. So try to work. I would request everyone to try to work on the areas where the CO2 or any of the impure emissions is being taking place, just to suppress those emissions. So this is what, that's why I have mentioned that there is a commercialized process and the advanced process. So advanced fuels or advanced biofuels are this kind of biofuels where the CO2 emissions or the other impure emissions is not taking place. Okay.
Once again, I request to all the participants kindly put up their questions. If you have any doubt or any related to curiosity in your mind, ma'am can easily solve your doubts. So I would like to request to all the participants kindly ask their doubts if they have. Does anyone have any questions regarding this PPT or any kind of question? They can proceed. So I think there is no any questions from any one of your side, and I hope so that this lecture has going to be boost up your knowledge and valuable information has been shared up by Dr. Amri Niazi ma'am. Thank you so much, ma'am, on behalf of our university. And we are really glad that you are sharing your valuable insights and valuable thoughts and valuable information that whenever we are listening to you, that we are literally all the time we are stuck to the screens. And thank you so much, ma'am, for giving us your valuable time to all the participants, and also in this faculty development program. Organizing committee of this faculty development program is highly glad for your contribution to all the faculty
Thank you so
members has
much.
been joined up in this session. Thank you so much, ma'am, for
Thank you
joining
so much.
us.
Thank you.
Also, I would like to say to all the participants that those participants who are not in this session are are considered to be an absent. Also, feedback form has to be shared up in a WhatsApp group, and from further after that, we should have to share the feedback form of the particular session into the Zoom meeting app, so that those participants who are joining in this session might be submit their feedback to the session. Also, the next session from our resource person, that is Kiran Kumar Allah sir. So soon he will join up in this meeting. So once again, ma'am, thank you so much. We
Thank you
should,
so much. Thank you. Thank you, everyone. Thank you.
one more request to everyone, kindly switch on their camera so that we take a proper screenshot of this session number 5 of day 3. So kindly switch on their camera so that we take a proper screenshot. Thank you so much, everyone.
Thank you so much. Thank you, everyone.
Everyone,
Thank you.
thank you. Once again, I am saying to all the participants, kindly switch on your camera so that we take a proper screenshot and make a proper attendance of yours. ठीक. Thank you so much, all the participants. for joining this faculty development program. I hope so. This session might be very useful to everyone, as ma'am suggests that the E20 might be in a core sector area for the ethanol blending and might be a research topic for all the participant and faculty members, and that they this will be in a core sector for the research also. And also, I would like to request that the next session should be start from very soon. And the next session, our resource person is Dr. Kiran Kumar Allah, sir. He will be also sharing their valuable thoughts and ideas to everyone. And thank you to once again to all the participants who has been joining from different states and make this session and make this faculty development program much more useful and much more wonderful to everyone. Thank you for your grand attendance in this session. Thank you once again. We will catch you soon in upcoming session number 6. There is an important announcement to all the participants that the feedback link has been shared up in this Zoom workplace meeting only, not in a WhatsApp group. So all the participants are requested to kindly join this session so that they can submit their feedback. Otherwise, they marked up as an absent. And you also know that 80% of attendance is must for this faculty development program. So that at the end of the session, you should have to be generated your faculty development program certificate from AICT et al. So for your feedback, you should have to be in the session. Particularly, you should have to be attended in this session, and the feedback form has to be shared up in this Zoom workplace meeting, not in a WhatsApp group. So once again, I would like to request to all the participants kindly be in a session, and after the end of the session, the feedback link has to be shared up in this Zoom workplace, not in a WhatsApp group. And one more important thing I should have to be in one more important thing I should have to be add up in this session, that if you don't have any 80% of attendance, you have been marked up as an absent, and your final certificate of appreciation not been generated by AICT et al. So that it's been requested to once again to all the participants kindly be present in the faculty development program, this online virtual FTP 2025. And also the feedback link has been shared up in the chat section, so everyone can go through the feedback link and they can submit their response through the link. I also shared up. You can kindly check there. And next session, for the next upcoming session, our resource person is Dr. Kiran Kumar Alas, and he will be joining soon in this meeting. And I wish this session will be more beneficial to all the participants who has been present in this session. Might be very useful and kind informative. As the ma'am said, kind of a research areas for all the participant has been joined up in this particular sessions.
Mm.
Once again, good evening to everyone. For the upcoming session number 7. Wait. Good evening, everyone. Am I audible to everyone?
Yes, sir.
Yes, sir.
Thank you so much, ma'am, for confirming. Good evening, everyone. For the next upcoming session number 6 for the day 3 of this Atal AICT FDP program. For the next session, we have a resource person, Dr. Kiran Kumar Allah, sir, who has a lot of experience, and he has been from Osmania University, and he has an electrical engineers and bachelor's in sociology. Also, he has an Indian School of Business, MBA Financing and Marketing in PGP 2008. For the brief introduction about this, let me start it from 1995 to 2002. He has been working as a Bakelite Helium Limited, and from 2002 to 2005, sir has been working in a Middle Earth HR consultant. From 2005 to 2007, he has been working up as a EV Computech and Sierra Atlantic. From 2008 to 2017, he has been working up with a Reliance Transmission and a BSES Delhi. And from 2017 to 2022, he is working up with a Bloom Energy Corporation. From 2022 to 2025, he has been working as a Plug Power Corporation, and from 2025, he has been working up as the Energy and the Resource Institute. So, guys, we have a very much experienced person as a resource person along with all of us. So I think so this session might be very useful and kind of informative to all the every participant has been participating in this FDP program, and I hope so this the today is the third day and you have been enjoying this session and learned a lot from these faculty development programs. So for the next upcoming session, we have an Dr. Kiran Kumar Allah, sir, and now I'm handing over this session to Kiran Kumar Allah, sir. Sir, can you hear me, sir?
Yeah, I can hear you.
Sir, on the behalf of Sri Satya Sai University of Technology and Medical Sciences, Sehore, we are welcoming you for this Atal FDP program. We are very thankful to you, sir, so that you are giving your much valuable time to this session, and to all the participant has been joined up in this Zoom workplace meeting. Also, as all you are aware that today's the topic is green hydrogen and renewable energy system, and I think so the Kiran Kumar sir has a lot of experience of technology. He has a lot of experience of industry also. He can share up to all the participants. I think so this session might be very useful to everyone, and I think so also that this is such a great opportunity, golden opportunity to everyone, that we are sharing our thoughts, our ideas, and our valuable information to everyone, so that we can make this session as a productive session. Once again, sir, on the behalf of coordinating committee of this FDP, we are welcoming you, sir, for giving us such a valuable time to this faculty development program session, sir. Now over to you, sir. You can proceed from here, sir.
Okay, thank you, Satya Sai University team, for giving me this opportunity. And I see there are a good number of participants, about 90 plus, and everyone is off video and everyone is muted. So, I mean, please remember, um, if you are fully present here, you'll be able to understand what I'm talking.
Yes.
Otherwise, you'll get the attendance, but you'll get nothing from this session. That is number one.
Right, sir.
right? Second, I definitely want this to be interactive. So I'll ask questions. I'll wait for you to either answer directly by unmuting yourself or putting it in the chat box, right? So what I'm going to discuss today is based on a lot of my practical experience. I'll give a little bit of my background. I started as a shop floor engineer, doing maintenance in a chemical factory. So that's where my journey began. Then I went to learning and development. Then I did my MBA, finance, marketing, and all. Then I went to power sector. In power sector, I initially started with power transmission, long distance power transmission, where it was getting privatized. So one has to set up the transmission lines and maintain them and all. So again, my role was mainly in business development, financial modeling, and a little bit of route optimization and all. Then I went to the distribution utility. I was with the Delhi Discom, BSC's Rajdhani. So again, I was back in a technical role. I was head of central engineering services. So I was doing the network planning, right? Where the load is coming, how do we expand, where do we put the next substation, and all those kind of things. So during that time is when I started looking at renewable energy, because renewable energy started happening. I think around 2010 is where I think the national solar mission got announced, and it is initially very very small because the solar cost was very high, like 17 rupees or even 20 rupees per unit was the initial thing, right? So that's where it started. But then by the time we got to the discom, I was in the discom. I was also involved in the power purchase. So one of the things that started happening was the renewable purchase obligation. So Discom had to buy a certain percentage of their energy from renewable sources, but they were expensive. So Discoms were in not having enough cash flow. So we were generally Discoms were delaying purchase of renewable energy, and so that was one challenge. But then the next question was, oh, okay, we will take renewable energy, but we generally saw that nighttime power was very cheap, and we were unable to use it fully, right? And daytime power was expensive and more people wanted it. So one thought that came to us was, oh, why don't we do storage? So we started exploring storage. We looked at battery as a storage mechanism, but we realized that the round trip efficiency, the capital cost, and all that was becoming very expensive. So that's where my mind was wondering that, oh, okay, if renewable energy increases, it started becoming cheaper and cheaper. If renewable energy actually becomes cheaper, then how do we use this in renewable energy? Because it is available. There are two challenges with renewable energy. One is uncertainty and variability, right? So now this is the first quiz point. So I would like to understand from any one of you, what is uncertainty and variability? How are they different? You can use, if you want, you can even use Google or anything, but I want you to come up and tell me what is uncertainty and what is variability with respect to renewable energy. So you can raise your hand or you can directly unmute yourself or put it in the chat box. I'll wait for a minute.
Renewable energy sources, they depend upon weather condition.
Correct.
So in that sense, we can say that they are uncertain.
Yes, very good. Because uncertainty means you don't know what is going to happen in advance,
Yes,
right? So whether suddenly cloud can come, suddenly some cyclone comes,
yes.
we can predict to some extent, but still there is a possibility of uncertainty. So now what is variability then?
Variability is that, for example, if we take the solar, so solar irradiance, it varies from during the day hours. That is maximum solar irradiation, you get it from 11 to 4.
Right.
And regarding wind, if you speak, then wind speed, it varies.
Right. Yeah. So full marks to you. I suppose your name should be Asha Gaikwad. Is that correct?
Yeah, Dr. Asha Gaikwad.
Dr. Aisha. Great. Thank you. Thanks for participation. Because a lot of times what happens is people know everything, but we don't know how to exactly put it. You put it rightly. So you get 100 marks for that. So Geeta has unmuted herself. Would you like to say something? Okay. So yeah, so the uncertainty and variability is a big challenge. So then I used to wonder, okay, how do we solve this, right? So renewable energy looks cheap. It is what we all want. But then battery is very expensive. How do we do it? So then slowly, as I was researching, I started coming across something called power to X, power to fuels, or something called electrofuels. I got interested. I said, okay, what is this? So it started talking about, oh, you convert electricity into fuel, some kind of fuel, you create methane and something like that, something. So you try to convert electricity into fuel and store it in that form. So that kind of piqued my interest. And around the same time, this company called Bloom Energy was trying to come to India. Initially, their technology looked very, very futuristic. I thought it was rocket science. In fact, they were supplying their solution. Their original solution was supposed to be done for Mars mission, where the electrolyzer was supposed to convert energy and synthesize either water and then reverse water to hydrogen and oxygen. So they were coming to India. They were looking for. So I joined that company because of that interest, and I realized that one of the ways it can work is you can generate electricity on the spot in a remote location as long as you have access to gas. So the challenge, one of the challenges of a grid is electricity is very, very good. It is very, very clean in terms of transportation, in terms of utilization and all. However, the biggest challenge is that you have to put poles, lines, towers, and all that. And you have to have a direct connection, uninterrupted connection between the generation point to the distribution point or the consumption point. So sometimes in heavily dense population areas, you stop getting right of way. That is one problem. Second is the consumption keeps on increasing. So instead of 100 kilowatt transformer, so 100 kVA, we have to now think about 250 kVA. And in Delhi, we started hitting the limit of, we used to have 990 kVA or close to 1 megawatt, 1 MVA distribution transformer. So even that was getting overloaded. So one of the possibilities I used to think was, oh, why can't we use natural gas? Because pipelines are there, put a fuel cell and generate electricity and supply. So that made me interested in that sector. So I went to Bloom. And while at Bloom, one of the challenges we realized was, oh, in India doesn't have enough gas. So we import 50% of our gas. So when we import 50% gas, it is expensive. And when you try to generate power using that, power also becomes expensive. And as all of you know, India's generation mix is dominated by coal and gas. Even though there is some capacity, currently they are operating very, very small number of gas units and production from gas is very, very minimal. So gas did not work. So fuel cells did not take off in India, even though there are some installations which use fuel cells along with natural gas. And around that time, I started exploring marine sector. Marine sector was interesting because marine sector had its own greenhouse gas emissions and pollution and all that. Because marine sector uses the worst possible fuel in the sense after removing all good quality fuel from crude oil, what is left over, that is what is used in marine sector. So in fact, that leftover fuel is so thick, it almost looks like tar. It doesn't even flow if you don't heat it, right? But I mean, what was the problem for refineries became a boon for marine sector because marine sector burns this fuel away from land, so no one really sees them. So and for refining guys, what product that is a problem to dispose became a fuel and a valuable fuel. So because they can sell it. So that's how the marine sector has been for a long, long, long time. So they have been using this crude oil. What do you call marine fuel is very blackish, right? So, but they were also trying to reform. So they initially reduced the sulfur content in the fuel. So that was IMO 2020. Around the time I came to marine sector to explore whether we can use fuel cells in the marine sector. So, and 2020, as we all know, COVID happened. And when COVID happened, I was just entering into the marine sector. We got a partnership with a shipbuilder. So we're exploring how can we use fuel cells for reducing marine emissions. But slowly and steadily, as the COVID became severe, if there was one sector that was booming, that was shipping. Initially, it also kind of went down, but then shipping rates went high. The containers became very expensive. They started making a lot of money, but it also brought a lot of attention onto the marine emissions because every other emissions was more or less down, very limited, but marine was running full. And then suddenly everyone said, "Oh, what is the alternate?" Right? So that is when the talk of hydrogen started happening in the marine sector. That was my observation. I'm sure hydrogen story might have come in other sectors as well earlier, but marine sector is where I saw some unique things. So I'll bring that into my presentation. So let me share my screen and let's get started. I hope you are able to see my full screen. Can someone confirm?
Yes, sir.
Okay, good. So, okay, so the today's discussion is titled as role of green hydrogen in energy transition, right? So let's go into it. So, okay, disclaimer is these not everything is my slide. So some of the ugly slides are been prepared by me. And again, this is not my opinion, not the company that I work for. And nothing in this is confidential. Most of it is public info and helping you make sense. And the scenario is always evolving. What is true today will change tomorrow because something will change. And feel free to ask questions anytime. And finally, do your own research, right? But remember that answers that are simple is where our mind generally goes. But answers that are complex but right, it takes a little bit of effort to stay on, because it is never black and white. It is always gray, right? Sometimes looking white, sometimes looking black, but somewhere here and there. And it is not a straight, simple path, right? So that is what I would encourage all of you to think about. Don't take anything on face value, but really look at, okay, what's actually happening. So let's before we jump into hydrogen, let's take few steps back. So let's first look at why are we thinking about hydrogen, right? So now let us think about the global warming, some basics.
Plus में रख लो मारो.
Yeah.
आंसर क्या जाने वाला है?
Mr. Harsh,
ऑप्शन डी इज द करेक्ट आंसर। अगला क्वेश्चन
Harsh,
कह रहा है,
you
क्वेश्चन
have to
आपका
go
कह
on.
रहा है कि व्यक्तिगत निर्णय संयुक्त निर्णय से
Yeah. Okay. So, I mean, see, greenhouse gases, a lot of people also get confused between pollution and greenhouse gas emissions. So, if there is anyone who would want to step forward and share what is the difference between pollution and greenhouse gas emissions, that will be very welcome. Anyone? Difference between pollution and greenhouse GHG emissions. No one? Or no one is hearing me?
Greenhouse gases, they are increasing the effect on the global warming, and
Yeah.
pollutants may be the local or overall effect on the climate or weather conditions, other greenhouse effects. It is leading to greenhouse effect, but greenhouse effect is not leading to pollution.
Okay. Yeah, I think you got 75 marks according to me. Please don't get me wrong. But I'll tell you why I said 25% part. Because some kind of pollution, sorry, yeah, Praveen.
Greenhouse effects means it increases the overall temperature of universe, means of
Yeah.
Earth.
Earth,
That
yeah.
ultimately it melts down the glaciers and may it cause or maybe it will cause different effects,
Yeah.
adverse effects in that case.
Yeah. Pollution,
And pollution is which causes direct effects to human body,
right?
harm human body. That's
Yeah.
it.
Yeah, you also got 75, 80 marks, no problem. But what I was looking for was one specific point. The specific point is that some pollutants are negative greenhouse gases, right? This is something I learned when I was in the marine sector, because the sulfur oxide, SOx emissions act as actually cool the atmosphere, right? So pollutants need not be greenhouse gases and greenhouse gases need not be pollutants. But yeah, they both are challenges to our work.
Sulfur may cool the greenhouse effect, but it is
Correct.
causing some other toxic effects
Correct,
like
correct.
respiration. This is a
Correct.
pollutant. This is
Absolutely.
causing effect of respiratory system.
Absolutely.
So maybe
It is a
it is
pollutant.
causing pollutant effect. Yeah,
Yeah.
it is a pollutant.
Yeah, it is a
So
pollutant, but
overall,
it is a negative
we
greenhouse
can't
gas.
say it is a good one. It is a good one because it is cooling the atmosphere or it is giving a negative effect to the greenhouse. So we can say that if the sulfur is emitted, it is good. No,
Yeah,
we
I
can't
mean,
say that.
We can't, I did not say good or bad. I just say it's a negative greenhouse gas. That's all.
Yeah, it is negative. That's okay.
Yeah, yeah. So absolutely. And again, please remember, good or bad is mainly from who is talking, who is the stakeholder, right? So what is good for humanity may not be good for plants or may not be good for animals. All those things are there. They are all ethical debates. We'll not get into that. But obviously, we are looking at a bigger picture and trying to see what is good for majority or most, at least, right? Okay, let's come back to the global warming part, right? So if you see, this is the ice core temperatures, and obviously there are many cycles of ice ages versus high temperature that has already happened, and we are looking at the last part of the graph. Let me use some laser or something. Yeah. So here, so this the last part is what we are right now looking at. And if you see, this temperature is actually looking pretty stable, right? Pretty much in a bound, range bound, right? Do you know what is the reason this temperature is range bound in the current known civilization time? Anyone? Why is the temperature kind of remaining in the range bound, unlike earlier cycles where it kind of went up and then started falling rapidly? Yeah, so one of the reasons actually is the human activity and especially agriculture, right? So, so that is what is keeping the temperature in a range, which is good for life in general. So that is where we are right now. But it is now slowly going to the higher side than what life can take. So that is where the concern really comes from. So broadly, global warming, right? So the trapping of heat is a problem, right? Not the amount of heat coming from the sun. So generally when it is hot, we blame sun, but actually trapping of heat is being caused by the gases that we are emitting. And as you all, I'm sure you will know this, CO2 is very small percentage. And the other greenhouse gas, which is water vapor, is part of the water cycle. So it kind of moves from 0 to 4%. And the challenge between carbon cycle and water cycle is carbon cycle is a long cycle. Water cycle is a short cycle. So things move very fast in the water cycle. So by usage of fossil resources, we are fast tracking the carbon cycle. Yeah. So that is one of the key reasons to be concerned about in terms of the global warming. So I'll one interesting thing that I found as a practitioner is combusting 1 kg of natural gas releases 2.75 kgs of CO2. So I was a little initially flabbergasted. Oh, why is this happening? I mean, I'm not an academician, I'm not a researcher, but I was a little surprised. Anyone want to throw a light on what is happening here? How can 1 kg of gas release 2.57 kgs of carbon dioxide? Anyone?
So that's related to molecular weights, obviously, and then you have oxygen coming in. So if you multiply the respective
Yes.
atoms, and yes, atomic weights. That's how
Yeah,
you get it.
it was funny. Yes, yeah, absolutely right. 100 marks. So I was funny. It was funny for me because we all think that oxygen is the best gas, but suddenly I realized, oh, oxygen is actually combined with carbon and then increasing the weight and multiplying the problem, right? So sometimes the narrative that is built that, oh, we call it carbon emissions, but instead we should maybe call them carbon dioxide emissions, or better, maybe greenhouse gas emissions is a better way to depict it, because I mean, there is no absolute right or wrong, right? So certain amount of CO2 is really required in the atmosphere, and anything excess is what is creating the challenge. So it's very important to have that balanced views so that we understand what are we trying to address. Otherwise, it will become a very strong biased perspective, and people don't understand. And especially students and all, they get carried away. They think that, oh, all carbon dioxide emissions should become zero. It can't become zero, right? It should be kept in control. Yeah. So let me go to the next slide. Okay, so this is one very interesting thing that I came across when I was in the shipping sector. Because if you see, I started with the international shipping, so that has about 0.7 billion tons of CO2 per year emissions. And the next one is actually higher than that is hydrogen as a sector. China obviously is the leading emitter because they are growing leaps and bounds and their energy consumption is very, very high. United States is the next biggest. Europe as a whole continent is the next biggest. So India is, no, Europe and India might be here and there, but broadly we are there. So other countries are lower. But if you see right after Japan, so that means about, if we can think about sixth, seventh country, hydrogen is the seventh largest emitter. Shipping is like the eighth one. So why is this statistic important is every country has its own way of energy, consuming energy, their resources and all those kind of things, right? Now, if what works in USA may not work in India exactly, what works in China may not work in India exactly, what works in India may not work in Europe for that matter, right? And every technology you need to adapt to local conditions before it can give similar benefits or similar outcomes. But when I was in shipping, I realized that whatever you achieve in one country, right, whether you are in India or Europe or Korea or Japan or China or US, the same thing gets applicable for the whole shipping sector, and shipping is a global sector. So what can be done in Korea can automatically go global, and the whole shipping sector can adopt the same thing. So that was a key benefit I saw with a sector like shipping. And the same is applicable with hydrogen, because hydrogen is a very, very homogeneous sector in the way that it is produced and the way it is generally consumed. So therefore, hydrogen offers a very high bang for the buck in terms of technology evolution to shift from high emissions to low emissions of hydrogen. So that is one of the key reasons hydrogen has got a lot of attention. And there are other reasons, but current consumption of hydrogen itself, if we move from gray or fossil fuel based to a green or renewable energy resources based hydrogen, it can easily reduce 1 billion tons of CO2, which is really good achievement. And once that get established, it can even go to other sectors. Okay, so that is the reason for this graph here. Okay. Now, these are some academic topics, but you see that this is not a new technology. Industrial water electrolyzer was developed in 1888, and even India had an electrolyzer long back. I think we were generating hydrogen to produce ammonia at that point. So fertilizers was a utilization, and the source of energy was hydroelectricity. So hydropower. So it was actually green at that point, but then later gas became cheaper, fossil fuels became cheaper. So the gray ammonia became easier to produce. So that went back. So technology is nothing new. And yeah, obviously discovered in 1766. So, and hydrogen essentially, it is the creator of water. And if you see hydrogen, very interesting. It's a combination of a gas, which is fire, and oxygen, which supports fire, but then it becomes water, which actually quenches fire, so it stops fire. Very interesting element, and it is the most abundant chemical structure in the universe. So it is there ubiquitous across. Okay, so that's some basics about hydrogen. So where is hydrogen used today? So currently, as we have seen, about 100 million tons per annum is the consumption, global consumption today, right now, and currently used mainly in oil refining. Interestingly, so for the crude oil to become petrol and diesel and many other byproducts, so hydrogen is one critical input. The next biggest utilization is in the ammonia production, and ammonia is closely connected to the agriculture sector. So that is across the world. Third one is the methanol production. So methanol again used as a chemical input and also as fuel and many other industrial applications. And a little bit goes into steel production, not for the mainstream, but there are some processes that need hydrogen. And rest of the 10% is for treating metals, even the dalda or hydrogenated oils also uses hydrogen, and other applications. Hydrogen, the advantages can actually be used as a fuel for electricity production. It can be used in transport, it can be used in building heating and many other uses. but that kind of usage is currently limited now, but has a potential to lower global carbon emissions if it is used in other applications, right? So yeah, let's move forward. So, I mean, there are a lot of colors. Again, these colors, there is no specific agency that is giving the color, but generally, there's more like an industry accepted colors. So, gray hydrogen is essentially coming from steam methane reformation. It is not SMR is not the other one. It is steam methane reformation or gasification. The other source is coal, either natural gas or coal. Coal gasification is also happening. I think China is the only place where coal gasification is happening in a big way. Otherwise, rest of the world is mostly converting methane to gas. The carbon intensity is pretty high in the gray hydrogen. So it is roughly estimated, there are different estimates, little high, little low, but rough estimate is about 1 kg of hydrogen leads to 10 kgs of CO2 emissions, right? So the next is the blue hydrogen. Essentially the gray hydrogen, same thing, but the idea is, can we capture that carbon dioxide emissions that are happening here? So that is what is potentially known as blue hydrogen. Blue hydrogen also can be blue ammonia. So there is some amount of blue ammonia production happening now, and that is actually being sold at a higher premium, the blue ammonia. The other one is turquoise, and there is also a pink hydrogen. There is also talk about white hydrogen. Again, the idea is you are reducing the carbon emissions more and more from 10 kgs to whatever less it can be. And finally, the green hydrogen, where we are electrolyzing water. The input actually is water and renewable energy. So therefore, the emissions from renewable energy are negligible, and the production process doesn't have any emissions. It's only hydrogen and oxygen. Oxygen is released into the air, and hydrogen is utilized as whatever the end product is. So that is the reason green hydrogen has come into the picture. Okay. So now before we go into the next section, let me ask a question here, and I want everyone to put your answers into the chat box. So my question is, we all know that today electricity is one of the main sources of energy that we consume, right? I'm talking about the total final energy consumption. Okay, so we all consume energy in different forms. So we know that electricity is a major part. But according to you, question number one is, what is the percentage of electricity as share in the total final energy consumed by by a by the whole humanity across the world? What do you think is the percentage? Is it per share of electricity in the total final energy consumed? So I'm looking at the chat box. I'm looking for some answer, some percentage, any percentage, whatever you think. Okay, someone said 80%, to 80%. Anyone else? 34%. Okay, 75, 34, 80, 80, 75. Any other number? So I'm a little, yeah, 75, 34 again, someone. Okay, 80 again. 25, someone. 70. Okay, so maybe another 5 more, and then we'll look at that slide. So 70, 25, 80, 80, 34, 75, one more, 80. Okay, the consensus seems to be around 70, 75, 80. Let's see what is the last one. Or someone came up with 20. Okay, let's see what it exactly is. Yeah. So take a look at this, right? So electricity, the last few years, it is at 21% of the total final energy consumed. I mean, I was very surprised because I was coming from the electricity sector. I thought electricity must be the major dominant source of energy. But I was surprised to see that it grew from 13% in 1990, about 125 years, it is reached from 13% to 21%. And despite the growth, right? And this is the final energy consumption. That means electricity itself might be consuming coal, oil, gas, and all that on the input side. We are not talking about the input side. We are only talking about the output side, right? So one of the main paths to decarbonization, if we want to decarbonize, if we want to reduce the emissions, one of the pathways everyone is thinking is that we start using more and more renewable energy. We start reducing fossil fuels in the electricity generation, reduce coal, reduce gas, and increase solar, increase wind, increase hydro, increase geothermal, or even tidal, all those kind of things, and thereby reduce the carbon intensity of the electricity itself. Does anyone know what is the carbon intensity of India's electricity generation? So it is measured in terms of kgs of CO2 per megawatt hour, or kgs of CO2 per kilowatt hour. So whichever, any number anyone can think of. What do you think it is roughly around? Let me see the chat. What is the carbon intensity of electricity generation in India? Point 0.75. Okay, 18. I don't know what that 18 is, but yeah, so let's maybe this is not one. Okay, one. Okay, so yeah, it roughly used to be close to one, maybe 0.95 or something, maybe 10 years back. So 0.9 tons of CO2 per megawatt hour, or zero point 0.9 kgs of CO2 per kilowatt hour. Right now, it has come down to around zero point 0.7 to 0.75, somewhere in between that. That is because of the renewable energy coming into the picture. So right now, I think close to about 10% of energy is coming from solar, and other renewable energy sources contribute a little bit more. And hydro is also being accounted. So currently, our energy intensity is about 0.7. Yeah. But a country like US, they have shifted significantly from coal to gas, and their carbon intensity has come down to 0.45, right? So we are at zero point 0.7, US is at about 0.45, UK is also something similar. So a lot of economies have moved from coal to gas, and they reduce their intensity, right? Imagine obviously the attempt is to reduce it further, and go further and further down by increasing renewable energy. However, the challenge is, even if you make electricity 100% clean, let us say we bring it to less than say 0.1 or 0, even then, of the total final energy consumed, we are addressing only 20% of the energy share, right? Unless the electricity consumption share increases, the only cleaning up the grid is not sufficient. So while cleaning up the grid is a good initiative, that is not sufficient, right? So assume that even if it doubles in the next 20, 30 years, by 2050, if you double the electricity share from 20%, it can go to 40%, maybe 50%. But rest of the energy has to come from other forms of energy. What characterizes the other forms of energy? Coal, for example, very interesting. It is a solid form of energy. Oil is mostly liquid form or some gaseous form, right? Natural gas is gaseous and oil is liquid. And biofuels and waste are mostly in the solid form, right? Heat is geothermal, right? Heat and electricity, the common challenge with these two sources is that you can't store them easily. That is the main challenge with these sources of energy, right? So considering this brings us to the role of green hydrogen. Okay, so IRENA has done some estimations. They said, okay, energy transition can be driven by low cost renewable energy power, lot of innovation in the form of energy efficiency, reduce the energy intensity of everything that we consume, and decarbonization of energy sector, and security of energy supply and affordability is also one key parameter, right? So we saw suddenly during the war, countries like Germany said, oh, no, we can't do clean. If we need to use coal, we'll use coal because Russia disrupted their natural gas. So they went back to coal in some cases, right? So energy security is also important and affordability is also important, right? But then let us say if everything goes as per plans and investments do happen, so their estimation is that by 2050, about 51% can come from electricity direct, and of which 91% can become renewable energy. So that's fantastic development, right? And only 12% will become fossil fuels, and 16% can come from modern biomass. This is one area that can grow significantly. And they estimated that about 14% of energy, direct use and fuels can come from hydrogen, and of which 94% can become renewable share in hydrogen, and 7% will be others, including geothermal and all that, right? So clearly, as you can see, um, and this scenario also talks about 11 times renewable energy generation compared with 2020. So right now, if India has done about 100 gigawatt or 150 gigawatt of renewable energy, imagine that it has to grow by 11 times, right? So that is a growth is possible in renewable energy, but we will also discuss a little bit on what challenges it brings, right? But this is a broad projection. Even in the worst case scenario, even if hydrogen doesn't happen as big as this, even at 5% to 10%, hydrogen is still, as you can see, is a big share. And one of the reason hydrogen has a lot of relevance is it can be in the form of gas or it can be in the form of liquid. I don't think it can become solid, but at least it can replace liquid and solid fuels. That is the main advantage of hydrogen. So that is where its role comes. That is how hydrogen becomes important, even though currently there is uh, some withdrawal or reduction in hydrogen production projections. So let's take a step back. Let's come out of this deep thing that we have done. Let's move and take a high level view on human civilization. And we also discussed right at the beginning, one of the reasons the temperature is remaining high because of agriculture as one of the things that humanity has brought. Because agriculture keeps certain amount of water vapor, certain amount of emissions and all that. So that kept the temperature more stabler than what would have happened otherwise, right? And agriculture is a very important transition in human community. And let us see if agriculture offers us some idea about energy transition. Let us see. Okay, so I'll spend some time here and yeah. So think about this. At the beginning of human civilization, um, mostly we were doing hunting, right? So I don't know why this yellow line has come. Is there a way to get rid of this? I've tried, but no, it's not happening. Okay, so maybe did I use a pen? Maybe I'll use an eraser. Yeah, so while I'll just try this while continuing, but I don't know where this came from. It's not going. Okay. Yeah, so humanity used hunting as the main source of food. Think about it. It is ready-made food. I mean, right now there is a lot of protein wave in India. Everyone, a lot of advertisements of protein, and yeah, animal protein is supposedly the best quality. Supposedly, I'm a vegetarian, but I still don't have a problem with someone consuming what they need to. But this was food that was readily available. All you have to do was get up in the morning, take your tools, go into the forest, hunt whatever animal is available, and bring it back and consume. So there is no uncertainty. It is always available, and it has been a lot of work has already been done by some other animal, right? So they have done all the work. They've created the food ready for you. All you have to do is go and grab it and bring it back and consume. Very simple, right? Now think about agriculture. Now agriculture has so much of uncertainty, right? You don't know whether rains will come. You don't know which crop will be successful. You don't know whether pests will happen and they eat away everything, or if something else happens and damages the crop. All the challenges of uncertainty, variability, and many other parameters, risk parameters are in agriculture. But think about this. Think about the guys who might have started experimenting with agriculture. So everyone would have thought, "Arey, what a big fool you are. I'm simply going to the forest and killing an animal and bringing my food. What the hell are you doing? You're a lazy guy. You're sitting there. You're saying I'll plant a tree or a crop, and then you wait for 6 months or 1 year for it to give out some yield, and only then you'll get food. What will you do in the rest of the say 10 months, 9 months, or 6 months? Right? You don't have food. You have to keep on giving the input and you get the yield only at the end. On the other hand, hunting is simple. You just go, you bring it. If you can actually dry it, you store in some form, all those kind of things. But agriculture solved something significant for humanity because it removed the need to be closer to the source of food. The reason being is agriculture created products that are transportable, that are storable, that can feed a larger population. On the other hand, hunting as the source of food has one big challenge. The um, challenge was that the the food that is available in the lean season, that means when the food is not available, decided the highest amount of population a society could support. That means if the food was very low, a lot of people could not get sufficient food. So that was what was happening during that time, right? So even though it looks very attractive, it has huge limitations. On the other hand, agriculture though looks very risky in the beginning, and once it has been mastered, once sufficient tools have been created, sufficient techniques have been created, sufficient processes have got developed, so it created a steady supply of energy for humanity to create civilizations that could be anywhere in the on the earth, right? So you need not be very close um, to the agriculture, so to the rivers. Initially all the civilizations were supposed to be closer to the rivers, but now suddenly civilization can be at a different location. Think about it. All the cities now are no more next to rivers, right? So you can be far off and still you can have a thriving civilization. And all this has become possible. One of the first things that happened is agriculture, and the second thing that has happened is energy in the form of electricity and other forms of energy, right? So somewhere this does offer us some learning. I simply put a fossil fuels versus renewables and green hydrogen, because fossil fuels are very similar. Fossil fuels have been got created by nature, and again all of us know that the single source of energy on earth is sun, right? All forms of energy get converted from sun. Even heat also is coming from sun. But what got stored over a long period of time has become fossil fuels. On the other hand, even the agriculture is also the source is sun. But again, this is a shorter cycle that humanity has figured out to do in a sustainable manner, right? So here again, I don't know who is unmuted. Okay, yeah. So similarly, renewable energy, the source is the same, right? Even the wind energy is in an indirect form, comes from the sun. But then if you are able to figure out how to convert it into hydrogen, I mean, you can call it green or you can call it some other name, but into hydrogen, then you are delinking the energy creation process from nature's processes, and you're also reducing the risk of disturbing the carbon cycle. So let me stop sharing for a minute. Let's take a pause here and see if there are any questions or any comments or anything. Any questions?
Hello.
Sir,
Yes, Mr.
Hello.
Narasimha. Yeah.
Sir, can you hear my voice?
Yes, please.
Sir, sorry, I have a small question.
Yes,
In one
please.
slide, you had shown that blue hydrogen product. The sources you had given, the sources you had given, methane and coal. Is it right, sir?
Yeah.
Yeah.
Any
So,
fossil fuel actually. Okay, it need not be only
yes, sir.
methane or coal, any fossil fuel.
Okay. In place of coal, if I replace the in place of coal, if I replace the energy which is come from renewable,
Yeah,
so that process, why? Because in renewable hydrogen, we are using the water and electricity. The splitting of
correct,
water process has been done through renewable power. Is it right, sir?
correct. That's right.
Yeah,
Correct.
yeah. It's in a gray hydrogen or a blue hydrogen. You had
Yeah,
given a source
yeah,
that methane with coal. So if I replace
methane,
that
coal.
coal with the
Yes,
renewable,
yes,
if the methane is the same, the methane process same. If I replace that for the production of hydrogen for
yes,
methane, I am giving a power of renewable.
yes.
Is it a workable?
Yeah, it is workable, right? That is what is green hydrogen, right?
Yeah, sir. But in green hydrogen, sorry, sir, sorry to interrupt. In a renewable side of a green hydrogen, the major process electrolysis process. So that
Yes,
electrolysis is nothing but a splitting of water into in a process of splitting of oxygen and hydrogen.
correct,
For that one, we are using a power for source is nothing but a renewable power. Like
correct,
it may be a solar or maybe wind.
correct.
So in a blue hydrogen or gray hydrogen, we are using a methane plus to process that one we are using a power. Can we use in place of coal? We use the renewable
Yes.
in the
I
either
mean,
gray hydrogen or blue hydrogen.
what? How will you use? Why don't you give an example? What do you have in mind?
I don't have any clear process of that one, but in place of the process gray
Yeah,
and blue
see,
hydrogen, it's a maybe a small doubt. I think.
no problem with that. See, here coal or methane already has hydrogen in it, and we are separating it, right? Renewable energy is producing
Okay, sir. Okay.
electricity. Renewable energy is
Yes, sir.
producing electricity. So, right,
Yes,
electricity
sir.
is electrons, right? It doesn't have hydrogen.
Yes, sir.
Hydrogen
Yes,
is
sir.
in water. We are using the electrons to separate the hydrogen. That is what is electrolysis,
Yes, sir.
right? There is another
Yes.
process which I did not include here, which is the biomass or biogas separation. So biogas can be
Okay, sir.
produced using bioresources, right? And if you
Okay,
use
sir.
renewable energy to break that biomass or biogas into hydrogen and even CO2, that CO2 is carbon neutral because it is coming from nature, it is going back to the nature, right? Short cycle, not long cycle,
Yes, sir.
right?
Yes,
So that is
sir.
also a
Okay.
you can call it as low carbon hydrogen, right?
Okay.
What
Yes.
is happening now is globally, no one is asking for green hydrogen. They are talking about low intensity hydrogen or low intensity ammonia. Okay. So low
Okay, sir.
carbon
Yes,
ammonia
sir.
or low carbon hydrogen. So this
Yes,
is
sir.
only for because everyone talks about green hydrogen. What is being referred to as green hydrogen is what I tried to present. That's all.
Okay, sir. And one more small doubt, sir. We are in the some like when I going research CCS, a carbon capture system. So
Mhm.
how it process of carbon capture system?
Yeah, carbon capture, CCUS, carbon
Yes,
capture
yes, sir.
and
CC.
utilization and storage, sequestration
Yes, yes,
basically.
sir. Yes,
So,
yes,
yeah, the idea is you take carbon dioxide, and one of the applications is you inject into oil wells. It will increase the production of oil wells. That is one application they are trying. The
okay,
other application
okay.
is you inject the carbon very down, highly below the ground, and it gets stored
Yes, sir.
there. No one knows what will happen.
Yes, sir. No, in the CCU, it may impact on the in atmosphere or it may use for good cause. Good cause, like.
I mean, see, one is the utilization. That means you can do, for example, in
Yes,
soda
sir.
manufacturing, you use carbon dioxide, right? And there are many processes where carbon
Okay.
dioxide is utilized. So you can use that. But again, the challenge is whether it is
Oh,
sustainable or not is not known. So that is one of the reason. And it has not been, it is carbon capture has not become very viable and scalable yet, even though a lot of money has been put. Okay. So that is
oh,
one reason carbon
okay.
capture has not become mainstream technology. Okay, so I think you should give now chance to others. Anyone else?
Oh,
Thank you. Yeah, I saw.
Yes,
Yes. Yeah, your name, please.
uh, my name is Ajit Kumar Gudekar.
Yes.
Sir, I don't know whether you will be covering that part in the next part, but I wanted to have your view or insight on nowadays we are using or people are promoting use of electrical vehicles.
Yeah.
And again, that electricity, if it's coming from renewables, then that's good. Otherwise, if we are burning coal for generating electricity and then using batteries and other stuff for storing that and in using it, then
Yeah.
what you call that as a life cycle analysis and that things.
Yeah. Yeah.
What's your thought on this?
Yeah, good question. I'll answer that question right now because it is not part of my presentation, but I'll answer that. See,
Okay.
electric vehicles solve two problems. Okay. So one is they are supposedly more efficient than the combustion engines. We all know that combustion engines are not that highly efficient, number one. So that means for the same distance, you might be using lesser energy, number one. That means the emissions associated should go down. Second thing is there are no tailpipe emissions. That means there is no pipe from which NOx, SOx, and particulate matter, along with carbon dioxide, along with carbon monoxide, along with hydrocarbons, are not coming into the local air. So one problem that EVs solve without any doubt, no one can debate, is there are no tailpipe emissions. That means the pollution will definitely go down, right? We discussed about pollution and greenhouse gases. However, EVs, if they are consuming from electricity from the grid, they are obviously not reducing the greenhouse gases. However, as the grid becomes more and more greener, like 10 years back, we were 95 kgs of CO2. Right now, we are already 70 kgs. And as we move forward, it can go to 50 kgs and even go down and down and down, right? So we are solving one problem right now, which is definitely pollution reduction. But as the grid becomes greener and greener, even the carbon emissions associated with electric vehicles will go down. So that way they have a value. And so, yeah, I mean, even though I would prefer hydrogen vehicles, but right now economically EVs are better viable than hydrogen or and also low pollution compared to IC engines.
Thank you. Thank you, sir. Right.
Yeah. Harshji, you have unmuted, please. Okay, okay, great. Okay, okay. No questions? Okay, I can move forward. Let me wait for a minute. Okay, so let me go. Let me share my screen again. Last time, I don't know, someone drew the line. So this time, by stopping the sharing, I suppose it will come back without the line. Yeah. So yeah. So maybe, someone played with the pen, it might have happened. So now the line is gone. So, okay. So why hydrogen? See, these are the arguments that hydrogen sector has been giving to say that hydrogen is the solution for decarbonization in a full manner, right? One, think about water, right? So, I mean, even though there is water scarcity in pockets, even fresh water is a challenge in many regions, and there are many fights, wars also happening on water. In general, we all can generally agree that water is in infinite supply, and water, even if it is evaporated, it comes back in the form of rains. So the cycle is faster. There is a possibility that we can manage it. So from that way, the raw material is infinite supply. And on the other hand, renewable energy side also, there is solar and wind. Once you set up the equipment, they keep on producing electricity. That is one side. Second, it can be produced with no carbon footprint from multiple sources. As I said, you can do biogas, you can do solar or wind and electrolysis, and you can even figure out other manners, even geothermal, and all those things are also possible. Third one is it is easily transportable in large volumes, unlike electricity. See, one of the whole globalization wave that has happened, one thing that has never been discussed but is real is that energy now is being one of the main commodities that is transported across the globe is energy. We all know that India imports a lot of energy, both in the oil and gas forms, right? So because this energy is being transported, humans can stay where they are and can use the same energy and live the same lifestyle. Otherwise, life cannot be similar across the globe. Energy is what made life more or less similar across the globe. So that is another advantage with hydrogen. You can continue to transport in large volumes from energy surplus locations to energy deficient locations. It has high energy density. From a gravimetric perspective, hydrogen has the highest energy density compared to all other clean energy sources. However, it has its own challenges. Volumetric density is low, so that is the reason it needs to be converted into some other form in order to utilize, right? So that is one of the arguments. Yeah, you can convert it into heat or electricity at the point of use without any emissions. When you burn hydrogen, you get water. When you use it in fuel cells, also the byproduct is only water. And lastly, it can be stored in large quantities and for long periods without any deterioration. So that is another reason hydrogen is being talked about as one of the main pieces in the puzzle of decarbonization. The other reason is its ability to store for long durations, right? So one of the challenges I discussed earlier was my discom days, where we were thinking, okay, how do we store all this excess solar energy or wind energy, right? Because if you guys know, in countries like Germany, where there is excess solar for some points in points of time and some days in the year, the electricity cost becomes negative. That means whoever consumes energy will get paid during that time. That is because there is excess energy in the system, and that will lead to that will disturb the grid and can lead to grid failures. A lot of, I mean, initially I used to think, oh, why can't you simply switch off the solar plant? But actually, switching off the plants and switching on large scale plants is not easy, and that creates the grid disturbances. So if you want to avoid grid disturbances, you want to maintain the equilibrium when there is excess supply. Just like when there is excess demand, you want to produce more. Similarly, when there is excess supply, the best thing to do is consume more. So they are, it's like an incentive for more consumption. So in that kind of scenario, you need storage. So batteries are a good, I mean, supercapacitors, for example, are the easiest ones because they can store a lot of energy, but for very short duration. The next one is a mechanical storage, which is a flywheel, but the next one is a battery. Obviously, battery is we all know we use it in various forms, and we have been using batteries from a long time. And now the technology is much more mature, the costs have come down. So why not battery? Battery seems to be the simplest solution. But the biggest challenge with battery is it is economically and technically viable only if you are looking at a daily cycles. So if you are charging and discharging on a daily basis, batteries are fantastic. But if you are looking at longer duration, like weeks or months, then what happens is the size of battery required will start becoming bigger and bigger and bigger. And because you are using only once or twice, less number of times, the capital cost on the units stored and utilized starts becoming higher and higher. So batteries are mostly suitable for minute storage in minutes and hours and maximum days, not more than that, right? So the next bigger source that we already have, that we already been using, is the pumped hydro storage. So that is already there. You can store it for minutes. You can't do it for seconds, but minutes, hours and days, and even weeks. So it can actually store during rainy season, and the next season you can actually utilize it. So some amount of energy storage can be achieved through pumped hydro. But the pumped hydro, the challenge is these are very large projects. They have ecological challenges, and they are very difficult to implement. So hydro is being explored all over the globe, but the pumped hydro storage is a new technology that people are exploring right now. India is considering creating artificial pumped hydro storage plants as well, wherever there are geological facilities available, where there is a height and there is a difference, a low area available, you can actually do pumped hydro storage. Compressed air is another one that can be utilized again daily kind of level, but the efficiencies are not very good. But hydrogen is something that you can use from hourly storage to a weekly, monthly, and even a seasonal storage. So that is the main reason, one of the main advantages of hydrogen. Hydrogen need not be in the form of hydrogen gas, but it can be in the form of other molecules also. So when I'm talking about hydrogen, I'm not talking only about hydrogen in the form of hydrogen, right? So that is one of the reasons hydrogen has been attracting a lot of attention and interest. So if you see what is the role of hydrogen, this this is a good study. I like this study. I try to see how we can think about hydrogen, because generally the moment we say hydrogen, everyone thinks about hydrogen cars or hydrogen based energy generation, right? But there are many other things that you can do with hydrogen apart from what is already being done. So one of the first application is reduction agent for steel, right? And it's a currently it is voluntary demand, but and the assets are also very long assets. So if once you do an asset in place, it'll take 20-30 years for you to replace. That is a big challenge. But other than that, this is something steel industry can adopt immediately. Wherever natural gas is being used, it can be replaced with hydrogen. And considering the regulations like carbon border adjustment mechanism of Europe, if someone is trying to export steel from India or steel products from India, they would benefit from using hydrogen or hydrogen derivatives, low carbon hydrogen essentially for steel production. The next one obviously is ammonia, because ammonia is, as you have seen in the earlier slides, is the second largest consumer of hydrogen, and ammonia is needed across the globe. So it's a global product. It is not only India, not only one country, it is across. So we can use green hydrogen as a feedstock to produce ammonia, and hydrogen is already being used here. So there is no learning required. People are already storing hydrogen. People are already using hydrogen. So all you have to do is replace gray hydrogen with green hydrogen. That's all. No change required. Similarly, it is a feedstock to produce methanol, and refining is obviously is been using hydrogen for hydrocracking and treating. So these are the top sectors in industry where the replacement potential is very high. The next comes is other chemicals. This is one interesting sector because chemical industry typically uses hydrogen in smaller quantities, but they don't do their SMR. They don't refine natural gas into hydrogen. So they typically either bring methanol or ammonia and crack them and generate hydrogen to use. They use in small quantities. So the application here is potentially there. So this is one area India is trying to do stuff now. Similarly, cement also is under CBAM. If you're trying to export cement, same thing. But again, it's a good fuel. Need not be 100% replaced, but some portion can be replaced. Similarly, other industries can also use wherever electrifications cannot be done. See, industry typically uses heat in the form of either electricity or heat. So if we cannot electrify, then and if you have to use only fuel, you can use hydrogen as a replacement. And if it is a chemical feedstock, if you are not using hydrogen for energy but as a feedstock, that is like in other chemicals, that is another area where hydrogen can come in. The other sector, the big sector potentially that can adopt hydrogen in a big way is mobility. Even yesterday, I was talking to the Pune Hydrogen Valley CEO. He says, we have done a lot of analysis. We even today find that hydrogen as fuel in heavy duty long haul transport is economical even compared to diesel, even though it is very expensive. It seems like expensive, but because of the efficiency, hydrogen is competitive to diesel except the initial capex and infrastructure required. So that is one definite area. Second area that I have worked quite a bit is shipping. So that is another area. Hydrogen can be used in the form of hydrogen or ammonia or methanol. I'm sure you guys might have seen the news of hydrogen ferry that has been recently introduced in Varanasi. So Cochin shipyard has already done some kind of ships using hydrogen and fuel cells. So that is another area which can happen. Aviation is another sector actively considering how to use shift to sustainable aviation fuel, and sustainable aviation fuel can be produced using green hydrogen. Again, this is one sector, there is a high potential for hydrogen. Cars, even though it looks very interesting and attractive, maybe electrical cars might be more economical because you don't use cars all the time. You use cars only few hours of the day, the rest of the time they are in parking anyway. So maybe that is the best way to do cars, unless the cars are working 24/7 continuously running. Trains is one area, but trains, if they are already electrified, their pollution is anyway zero. Only the source has to become renewable. So that anyway is happening. So trains and cars, trains only if you are using coal or diesel and you cannot electrify the route. Some routes you cannot electrify because of geographical reasons. Maybe there it can become a hydrogen train. Lastly, residential, commercial, where you cannot take electricity, remote locations, or defense locations, for example. Defense is a fantastic application because defense, you don't want sound, you don't want engines because they will create sound, or there is smoke. So if you use hydrogen and fuel cells, you can actually produce electricity without major sound or any smoke. So that is a fantastic application potentially as a electricity generation. And lastly, as a balancing for excess generation, and also when there is high demand, you can use hydrogen to produce electricity. So these are broadly the various applications of hydrogen. Okay. So this is like a comprehensive list of what all is possible. And some countries are considering burning ammonia in their thermal plants in replacing some amount of coal. And some countries are considering, can we blend natural gas with hydrogen and use both in industry, residential, and even in power generation. So these are all happening. So this is one possible scenario that can emerge, where on one side you have power grid and on the other side you have gas grid, right? So gas could be in the form of methane or hydrogen, right? So on one side you have all the generation sources, and in between is the conversion and storage, and lastly the consumption kind of thing. This is one way to think about the whole picture. Another way to think about this is this. This is from the US Department of Energy. If you see electrical grid, you have input renewable, nuclear, fossil, storage is bidirectional, right? And power generation is the input. And so that is one form of energy. Hydrogen can be input for vehicles, synthetic fuels, for industry, refining oil or biomass into better fuels. Similarly for ammonia, metals refining, other end uses, and also heating. But it can also be used to generate power and feed it back to the electricity grid. So both hydrogen and electricity can be codependent, and they are not competitive, they are actually complementary. There will be some places where they might compete, but most likely they will end up being complementary. And this is another way to think about how the energy value chain can look like. So you have renewable energy, you have electrolysis, and even from fossil fuels, you can have sustainable carbon capture can happen. And without transformation, it can go directly into shipping, trucks, pipeline. But with transformation, if you bring some sustainable carbon and use it here, you can create synthetic fuels like methanol, even green methane, or even biodiesel also is one possibility. Or you can convert it, combine it with nitrogen and make it ammonia, and which can be stored and transported and utilized in all the sectors that we discussed earlier. And okay, so before we come here, I will again take a quick pause, stop sharing, and any questions, we'll spend 5 minutes here and then go forward. Any questions? Anyone wants to raise their hand, unmute? Okay, no
Sir,
questions? Yes. Yes, please.
while running the trains, what type of hydrogen energy can be used instead of electric energy?
I mean, see, if electric energy is already available, then you are directly using it. So there is no problem, right? Your pollution is zero, right?
Yes, yes.
So no one is proposing to replace electric trains with hydrogen trains, but there are some locations where electricity might be a challenge. For example, in cold regions where there is a lot of snowfall and all, right, running electrical lines might be a challenge. Similarly, in hilly regions where there are a lot of trees, a lot of other things that are happening, electrical lines might be a little challenge. So there, even now, there are many diesel-based trains that are running. So in place of diesel trains, you can actually run hydrogen trains. So in India, there is one trial that is going on. So there, they are trying to replace the engine with a fuel cell. So the drivetrain will be electric, but the electricity will be produced by hydrogen on board. So you have hydrogen stored, and you have a fuel cell that is converting it into electricity, and that electricity is being used to run the motors and everything else. But what is also happening is, of late, a lot of interest has gone to combustion engines using hydrogen. So the
But then
analysis,
using the fuel cell, will it not increase the load of the train? Because
uh,
multiple fuel cells and multiple things will be used for charging it from electric to hydrogen or hydrogen to electric.
no. We are not going to convert electricity to hydrogen on board. So you'll produce hydrogen outside and you fill the hydrogen in the train like you'll fill diesel or coal. And there is
In the
only,
form of gas.
yes, in the form of gas. Yes, that's right.
Then is it safe?
Yeah, I mean, see, think about it. Is petrol
Then it
safe?
should
Is
be
diesel safe?
insulated trains.
Sorry?
Then the train should be insulated.
I mean, not required, right? So if it is in the gas form, why do you need it to be insulated?
Sir, hydrogen gas is inflammable.
Only when it is exposed, right? If it is stored and controlled, there is no problem. In fact, I'll tell you, there is a lot of misconception about hydrogen risk with hydrogen blasts. In research, it has been seen that because hydrogen is very, very light, if there even there is a hole, if it is leaking, it actually gets dispersed into atmosphere very, very fast, right? In fact, I've seen videos where a hydrogen tanker has a hole and hydrogen is leaking and there is a fire, but it is simply safely burning away rather than creating to an explosion. Explosion happens when a lot of energy gets released in a very short period of time, and because hydrogen moves very, very fast because it's a light molecule, it gets released into the atmosphere and it doesn't lead to explosion. Yes, there are the problems with hydrogen is the hydrogen fire doesn't have any color. That is the biggest problem. You can't see hydrogen even if there is a fire. So one of the safety mechanisms is to have hydrogen detectors. So that is one of the key challenges in hydrogen.
Yes, it's like burning in the same way our LPG gas is burning on the stove. They are also leaking through the hole and taking only that part of the flame.
Exactly.
Like
Exactly.
this.
Exactly.
Yeah.
Yeah. And in fact, see, compared to LPG, LNG is more safe because LNG is lighter than LPG. LPG, what happens? It is heavier gas. It settled down in the house. So that is the reason you see a lot of LPG explosions. But natural gas is lighter. If it even if it leaks, it goes and mixes in the atmosphere and gets away. Hydrogen is even lighter. So hydrogen leakage generally, I'm not saying you should leak it and forget it, but you'd have detection. But in terms of the risk of accident, hydrogen has lower risk.
It is also odorless, so it will not be detected also.
Yes, that is another bigger problem. Yes, orderless and colorless. So you need to have detection. In fact, that is what my previous company, Plug Power, used to do because we were using it for as using in forklift trucks, and these were indoor, right? And we used to have 1 kg tank, and you fill the tank and use it in the fuel cell. So we had hydrogen detectors and close to 60,000 forklift trucks using hydrogen are operating in USA, right? And the customers who are using are Amazon, Walmart, and many others. So it can be safely used, and they have been in operation for more than, I would say, what, easily 10, 15 years. Okay. So let me move on unless there are any other pressing questions. Okay. So let me go back. Okay. So yeah, so this is what we saw. So, okay. So now let's look at what are the global priorities. Okay. See, why there is a lot of hope, again, a lot of pessimism, a lot of challenges is we are not, it is not a simple solution. It is not something we can say, oh, let us all move to clean energy and from tomorrow let us change everything. It is not possible. The energy system is very, very, very complex and there are many drivers. If you see the macro drivers, obviously decarbonization is the main driver. No one wants Earth to become uninhabitable. We want Earth to be green. We want Earth to be healthy. We want all of us want to survive, not only survive, we want to thrive, we want to enjoy and all that. Not only for humans, but also for all other forms of life, including plants and everything, right? That is one main driver. That is the reason driving decarbonization. But energy security is also very important. Without energy security, there are high risks of problems for in large scale. So that is critical. Energy independence is slightly different than energy security. Independence is if tomorrow supply chains get cut off, what do you do? So you need to have your own independence and autonomy so that for a certain period of time, you are able to survive without, even if there are no supplies. So that is one of the reasons driving India to do much more than what other countries are doing on hydrogen. Similarly, energy access and affordability is another dimension, because not everyone has similar energy access, and even if it is accessible, if it is not affordable, it is benefit only few people, not everyone. So finally, energy equity and environmental justice is also required. So those are some macro drivers. But when you look at the industry wants reliable energy, resilient energy. That means even if there are some hiccups like value chain issues, they want energy to be available. Third one is they want efficient energy. You don't want you use lot of material to get the same output. You want more and more efficient energy. Similarly, direct electrification of energy. The more and more electricity you use, the better it is, because it is increasingly becoming cheaper and it is increasingly become cleaner. And finally, biofuels and synthetic fuels. Biofuels. Can I request, please mute yourself.
Call by his name, Dr. Amit, mute yourself.
I don't know whoever that is, but
I would like to request to everyone, kindly switch off your mic, please.
yeah, okay, let me try to continue, but I hope, yeah, thank you. So, yeah, biofuels and synthetic fuels to decarbonize hard to abate sectors is one option. Like, for example, synthetic aviation fuel is one thing that is being considered aggressively. Sectoral drivers, the energy sector itself also has some needs to use hydrogen, because increasing share of cleaner sources, especially solar and wind, means there will be periods of high energy and periods of low energy. Okay. And that means accommodating increasing share of variable renewable energy into the power system needs a resource that can quickly respond to increase in supply or quickly respond to decrease in supply. So this can improve the grid resilience. So that is one main thing. And more we are seeing strong and interconnected grid. So there is interest in making electricity the main source, and energy storage is critical. And finally, we have to transport renewable energy over long distance. Sometimes, should we transport molecules or should we transport electrons can become a challenge. So that is another reason power sector is looking at hydrogen as one of the solutions. Right. So let's go to the next one. So there is growth. There is increasing share of RE, limits of grid to integrate RE. In India, already people are saying, oh, there is more than 15% RE. There will be challenges because grid instability will come, right? You have to back down other power plants and all those kind of things. But at the same time, renewable energy is becoming cheaper and competitive. That means you can't ignore it. You can't reduce it because it is difficult. You have to figure out a way to use it, right? So green hydrogen can become a demand driver for renewable energy. Instead of selling renewable energy as electricity, imagine you are able to convert it to hydrogen or convert it to ammonia. So a renewable energy player in India can not only access India as a market, they can access global markets, other countries as markets. So that means it becomes a higher value added product, right? And finally, flexible electrolyzers as large scale demand resources, and hydrogen and derivatives as renewable energy carriers. So instead of transporting electrons, you can now transport molecules. And one of why electrolysis is the most I would say popular solution right now is it is the most scalable. That means you can go from kilowatts to megawatts to gigawatts, and it's also pretty mature technology among different hydrogen pathways. As hydrogen is adopted as energy carrier along with electricity, other pathways, that means other ways of producing hydrogen, will also benefit, because you will have hydrogen pipelines, you have hydrogen dispensing stations, you have hydrogen storage being available. So if electrolysis grows or hydrogen infrastructure comes in place, all forms of hydrogen production will also start benefiting from that growth. So the last slide that I have is what will be the positive spiral for hydrogen, right? So obviously the initially industry should shift to green hydrogen from gray hydrogen because industry is already using hydrogen. So no new technology change is required. All they have to do is shift from gray hydrogen to green hydrogen. That means only thing that is needed is large scale electrolysis that needs to happen. As large scale electrolysis happens, it will lead to cost reduction. It will help in creating wider and global supply chain. It will also allow us to build a lot of experience and expertise. So there will be more people who know how to work with hydrogen, how to do the plants and all this kind of thing, how to maintain hydrogen plants and all that. That means it will reduce the cost. So what is taking a lot of time now will become much more easier and faster. And it will also lead to standardization. Instead of project approach, it can become a product approach. So from a project to product itself, the cost reduction will be significant. So that is what is needed. So initially we need to achieve scale. And then the second important thing is the pipeline. So once hydrogen pipelines start happening, because that is the easiest way to transport. And the advantage will be one, it will reduce the cost of transportation and it will become widely available. And you can co-locate hydrogen production at renewable energy. That means you can put solar and hydrogen at one location. You don't need to run electricity lines. At remote locations where laying transmission lines is difficult, you can simply produce hydrogen using solar or wind and transport hydrogen. And you can also keep these pipelines close to the sea. You can therefore even ship the output from these locations. And pipeline also means easy to store. In fact, pipeline also acts as a storage in natural gas right now. So similarly, hydrogen pipeline also can become indirect storage. And finally, this will help adoption by transportation sector because hydrogen will be available at every location. So shipping, long distance, aviation and all. The last thing is the ecosystem becomes sustainable, not only from the climate perspective, but as a business model or a technical model or ecosystem model, it becomes sustainable. It can become one of the mainstream energy carriers. It will become complementary to grid. It will fill in for grid. So where grid is not available, you can use it for heat or electricity. And wherever grid is available, it will become complementary to electricity. And not only that, what we have seen, for example, with batteries, mobile technology, for example, and digital technologies and internet, once a resource becomes widely available, there will be a lot of innovation. People will figure out how to use this resource in different ways that we don't know right now, right? For example, hydrogen based drones, they can stay in air for much longer than battery based drones. That means you don't need more number of drones. With less number of drones, you can achieve the same thing, right? So, and even deep sea exploration, because now you have much more denser resource available, you can use it. Finally, it is an enabling energy resource. So hydrogen becoming available can help energy access in remote locations. So that is another way hydrogen can play an important role. So we are towards the end of the hour. So if you have any questions, that's my email. I'm also on LinkedIn. If you are interested to connect, please connect with me. And yeah, so any questions, happy to answer. Yes.
Does anyone have any questions regarding this session?
I'll stop sharing. Yes.
The way beautifully Kiran
Sir,
sir.
one question.
Yeah. You have to say
Yeah,
your
one.
name and where are you from and ask the question.
Myself, Dr. Ramesh from Vigyan Vadlamudi.
Please go ahead.
Yeah. So always we talk about hydrogen production and all right. Somewhere it has to leave some carbon footprint to the carbon footprint also, right, sir? In production, maybe there are no other direct way green hydrogen we talk about. Does it eliminates the complete carbon footprint?
Yeah, I mean, see, yeah, it doesn't. It doesn't. That's a reality because I mean, if 10 people are involved, we are also emitting carbons, right, during that time. So carbon emissions are there, but the idea is to bring it down significantly, right? As
Yeah,
we agreed, some
maybe
amount of carbon is not a problem. Can I complete my sentence? So in India, for example,
yeah, sir.
we have adopted a standard saying that anything below 2 kgs of CO2 per kg of hydrogen is green hydrogen. Europe has taken a little bit more lenient approach right now because obviously you can't expect an infant to swim in the ocean. So they said, okay, I think around 4 kgs is their limit from 10 kgs. Okay. So different countries are
Okay.
using different standard right now. And US had a slightly different approach. They said we will give more incentive for low carbon hydrogen and less incentive for high carbon hydrogen. So yeah, it is not zero carbon emissions.
Okay. Thank you, sir. Thank you.
Yeah.
Good evening, sir.
Yes.
Sir, I am Sukanya from Mallareddy Engineering College, sir.
Yes.
So we are creating hydrogen to there is emissions from hydrogen to ammonia. How, sir? I am doubting in that.
No, there is no
The
emissions
emissions,
from no, there is no emissions from ammonia to hydrogen, but the hydrogen used in ammonia already has carbon emissions.
We are going to make thanks.
Was it clear, Sukanya?
No, sir. No, sir.
See, in producing ammonia, you need hydrogen and nitrogen, right? And the hydrogen is coming from natural gas. So when you are producing 1 kg of hydrogen from natural gas, you are producing 10 kgs of CO2 already. So that is the hydrogen we are using in ammonia production. So therefore, that's the carbon emissions of the ammonia right now.
Yes, sir.
Carbon emissions.
Yes, yes.
Okay, sir. Thank you, sir.
Yeah.
Does anyone have any questions?
Sir,
Yes.
Yes.
sir, can you tell me what are the basic facilities required to start research in green hydrogen?
I mean, see, the best place to go with this question is to MNRE has offered a lot of R&D programs, right? And where did I see any green hydrogen? So some companies have been doing it, and nice National Institute of Solar, they are trying to do something on green hydrogen. IIT Bombay, I've seen something. So basically all you need is an electrolyzer. Small electrolyzers are available. There are PEM electrolyzer based, and you need a small hydrogen storage equipment and the safety required. Lot of institutions are setting up hydrogen related equipment. Basically small electrolyzer is what is needed along with the storage. And not only that, hydrogen is nothing new. All thermal power plants have small electrolyzers. They produce hydrogen and use it for turbine cooling purpose. Okay, so it is not a very complicated thing in small quantities.
Okay, sir. Thank you.
And I would encourage all of you to visit National Green Hydrogen Mission website of MNRE. They
Yes,
have put all the reports, all the research, and a lot of stuff there, right? You can get a lot of information on hydrogen there.
Any other questions? I think we should have to conclude, sir. Thank you so much. It is the time to thanks to everyone. So
Sorry for interruption, sir.
Sure, sir.
This is Dr. Suresh from Punjab Engineering College. Sir, can you repeat the name of that portal? I wanted to note it
National
down.
Green Hydrogen Mission's website.
Okay, okay. Thank you.
NGH.
NGHM, yeah.
Is that clear, Suresh, sir?
Yes, sir. Thank you, sir.
Okay. So can we conclude?
Yes, sir. We reached to
Okay.
our time limit. Thank
Okay,
you, sir.
okay. Actually, it's already late night. And once again, I would like to, on the behalf of Sri Satya Sai University, we are very thankful to Kiran Kumar sir, who make this session a very productive and very useful and very informative to everyone. And apart from this, you are solving the doubts in between the session and make this communication as a two-way communication after interaction with the participants. We are really thankful to you, sir. Also, on the behalf of university, we would like to thanks to our Honorable Vice Chancellor, sir, Dr. Mukesh Tiwari, sir. Under his mentorship, under his guidance, we are organizing this productive session like a faculty development program in our universities. Also, we would like to thanks to our coordinator, Dr. Sachin Kumar Baraskar, sir, co-coordinator, Mr. Manoj Kumar Ganwane, sir, also the research director, Mr. Mohit Gangwa sir, and the Dean School of Engineering, Dr. Rajan Singh Kuswa sir. I am your host, Tej Deepak, has been signing off. And I hope so that this session has been so much productive to everyone and can learn a lot from this session. And the PPT of this session has been shared to you as we get from Kiran sir, if you allow to us. Because I think so that this session has been so much productive that we have learned a lot from your side, sir, whatever you have, because you have a lot of experience you have, and you shared everything to all the participants, and the continuous support to all of the participants has been into this faculty development program virtually. So one more thing I have just want to add, that thanks to every participant who has been continuously from 7:30 to 9 continuously has been added up in this Zoom meeting. And also I would like to say that the feedback link of this session has been shared up in the Zoom meeting, because this the feedback you have been mentioned of the session has been marked up as your attendance. So no feedback link has been shared up in a WhatsApp group. Everything, whatever we are doing, has been turned up into the Zoom meeting app. So I would like to request to everyone, kindly submit your feedback about this session. And once again, we are really thankful to Kiran Kumar sir. You make this session as a very productive and very useful, and we are really glad to you, sir. Thank you, sir, and good night to everyone.
Yeah.
This is Desh Deepak signing off. Tomorrow we will meet up with a new resource person on the same platform. Thank you so much.
Thank you.
One more thing I just want to add up. Kindly switch on your camera so that we make a proper screenshot of this session.
Sir, link, can you please share again in the chat section?
Sure, sir. I send it. I shared the link into the chat section. You just proceed from there. And I just request to everyone, as the feedback is the best way to communicate with the resource person, so that we can understand that the whatever you gained from our resource person, Dr. Kiran Kumar sir, has been value a lot.
I'm based in Hyderabad, just for everyone's information. If anyone wants to get in touch with me, yeah, you can take my contact.
Sure, sir. We are really glad, sir, to give us your valuable time to this session. Thank you, everyone. We have taken a screenshot, and good night to everyone once again. And keep.
Bye.
Thank you, sir.